results are released for qualifiers, I think those who did not qualify has to appear for the qualifier once again in the reattempt session, which is quiz 2 for us and reattempt for them. So I don't think
Okay, okay.
they are able to access week 5 onwards.
Okay, okay. Qualifier results are released. Okay, results are released. You can check if he is correct. Everyone can join the session because classes link is calendar. Okay, I guess
Sir,
people
they
who
can
have
access.
added calendar. Okay, okay. Nice. The thing you did not got your study email right till now.
Sorry, I have.
You are term student or qualifier?
Sir, J based.
I'm term
J
student.
based. Okay, okay, okay. Okay. So whoever are term student they don't have right now, right? Okay, okay. You will get soon after after results you will get soon.
I got the email, student email.
Okay, okay, okay. Then fine. Okay, so is the week 5 session content are released for week 5?
Yes, it's
Yes,
released for
sir.
week 5 and 6 also.
Yeah.
6 also. Okay. When 5 released?
5 released even before quiz 1.
Okay. Same day, Friday.
Yeah, Friday. Every Friday they release new week content.
Okay, okay, okay. Week 6. So you guys have more session this week or most probably in the upcoming week because we together have to cover this week 5 and week 6 in
Yeah.
this week only, right? So
Yes.
probably you will have more session. Like this is your first session for week 5, I guess. Yesterday, state instructor was busy, so the session was cancelled. So
Yeah.
yesterday's session is happening today. Now tomorrow you also have one session, I guess. Or Friday I will take that session. Tomorrow most probably Shamiksha or Vishal sir, don't know. Anyone of anyone can take that session. Will take the session.
Okay.
And Saturday most probably Shamiksha will take the session. Or Sunday, I don't know exactly date. Yeah, but yeah, for today's session and Friday session I will take. Friday morning session at 7 o'clock. And apart from that, Vishal sir and Samiksha will take the session. Okay. This is the general information from my side. So basically, week one. Have you seen that week's slide content? Like how much did you watch? So that I will get some idea about it, like from where I have to start or how I have to start. Any idea?
So sorry, can
Any?
you repeat please? I got disconnected.
I'm asking. Did anyone start watching the videos or start going through the content, course content?
Yeah.
Did not
So didn't
open
start
any
yet.
lecture.
Gone through the
Sorry?
course content.
Okay. Only started with English lecture. You didn't started math and content. Okay, okay, fine. So we have to go in a
Actually, I
slow
did
pace,
not
right?
watch the videos, but it was today there was a TA session in the afternoon. I attended that, so uh, we have the
Okay.
idea.
So we have go through in a slow pace, right? I was thinking like if you guys have watched the videos so that I will speed up the lecture.
Sorry, sir.
No, sir, please don't speed up the lecture because even if we watch the videos,
Okay.
that doesn't help us that much.
Okay, 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 okay. Okay, so let me open the slides then I start. Okay, let me see the what are the contents. Okay, basically in this week you will have one session. No, sorry, one function, reversible function. Okay, let me write here and then we will. Okay, okay. So basically our first topic will be one-to-one function. Okay, basically you already have a bit idea about this one-to-one function, right?
Yes, sir.
In week 1 or week 4, maybe like in week 1 especially, I you already read about this. What are the one function and on two function? Then we have one. Okay, we have one vertical line test. What are this? vertical line test. Then we have horizontal line test. Okay, as you have like you already gave that qualifier exam for Math 1. So do you have any suggestion like for you guys like from which topic you face difficulties and all? So that we will improve for quiz 2. It will be beneficial for you as well.
Uh, it I
Domain
faced
and
difficulty.
range, sir.
One by one, one by one. Reversible. One by one.
Yeah, domain and range very good.
Okay. So basically, what do you want? Like more practice part or what kind of session or conceptual part? Okay, so
Practice
you
can help this.
domain and range, right?
Yes.
Okay. Then please let me know so that we will improve this. We will try to cover all those things in for your quiz too.
So there was a question where they were asked for t and t square. I mean the point of the triangle, I guess.
Yes, that
And
was a
the
tricky question, but
yeah,
it's a very good
the
question,
concept
right?
concept was clear, but it was kind of difficult at the time to solve it.
Solve it, yeah. Same for
Okay.
me.
So you don't have right now that question, right? You don't have that question, right? Practice is required, sir. We have, sir. Okay, okay. Just paste it later. We will see. What is that question? I don't think so. That question was too tough. Like I have seen that question paper. Okay. So except for 2 to 3 question, like yeah, except
So
two to
question,
three question, all question was straightforward.
yeah, question paper was so easy and moderate, but it's like that. Some questions were tricky, but
Mhm.
elsewhere it was okay for me.
Okay. Then we will. Can you paste that question? So, okay. Then we will have exponential function. Please mute yourself. Here I am writing just topic. Okay. What we have to cover today.
Inverse
Exponential
function.
function.
Inverse
Yeah, that
function.
we will cover. Exponential. Then after that,
Composite
what
function.
else?
Composite
Natural
function.
exponential. Yeah. Then graphs. Okay. See, whenever we will discuss some function, firstly, what thing we have to discuss? Any idea?
Graph.
Graphs. Other than that? Other than that?
The domains and
Domain
ranges.
and range.
Domain and range, right? So basically, we have to discuss for domain and range. And then we have some properties of exponential function. Other than that, we have composite function, right?
Yes.
Composite function or composition of function. Okay. I hope this session will be helpful for you. So please be there till end with me. Then after the composite function, then again we will talk about domain and range
Domain.
for
Mm.
domain and range for composite function. See, codomain part is not so important because codomain can be anything, like any superset of a range set can be work as a codomain set. Okay, so codomain part is not so useful. We need range and domain especially. Okay, but finding the range part is more difficult than finding the domain. Domain part we can find easily, but the range part is slightly tougher than finding the domain. Okay. Like even there are so many functions for that we are not able to find the range part. Okay. So that thing you need to remember. So don't worry if you are not able to find the range. Okay, composite. Then inverse function lastly, right?
Yes, sir.
Inverse function. Apart from that, is there anything left?
Only inverse function, sir.
Only inverse function, right?
Yes, sir.
Okay. Inverse function. So should I start directly or I just solve that particular question? What thing you want?
Solve it
Whatever you
once.
will tell, I will. Uh,
Solve it
So I
once.
guess you have, if possible, you could solve the question at the first, then you can proceed with the week 5.
okay. So I will take that triangular question only. Okay. This one, right?
Yeah.
Like this question can be solved, but like the question will be solved on the TA session as well. But still, if you are saying like this question is tough, so I am taking this question. Are you able to see this question? This is the question, right?
Yes,
Yeah,
sir.
the question was like choose the point P, like all possible point P's.
Okay, what is the question? You see, I think this is not the only question. It has
So I have
some
sent it.
parts.
Yeah, I've sent it later. In the next pic you can see it.
Yeah. I'm not able to share. Wait. Okay, now everything is visible to you. This one and this one.
Yes, sir.
This one. This one is visible. That's question and the another part. Both are visible, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Okay. Let's see. So okay, this is the only one. No? What is the question? Consider, okay, I am giving you the brief idea. Okay. I will give you the idea what is the idea here, and then you try to solve it. And if you like still after that you are not able to solve, ask me in the Friday's class. I will solve. Okay. Then now it's fine. I think that will be good for you. No, otherwise, if I will directly solve the question, I don't think so. It will be good for you. It's not.
Yes, sir.
I'm
Yes,
not
sir.
able to zoom it. I don't know why I am not able to zoom it.
So in the second part, the question is nothing much. Like it's just asking to choose all the possible points, nothing else.
Okay. Okay. Let's see. Let's see. What is the question? Consider two triangles are there. Okay. ABC and PAB. So basically, ABC and PAB are two triangles. So suppose this is your point A, this is your point B, A, B, and this is your point C. So this is one triangle. ABC and PAB, right? So here somewhere here, suppose point P is there. So this is your another triangle. This is PAB, right? Okay, so shall I use the different color for that? Suppose this is your another triangle, PAB. Now, what next? So you have ABC, PAB. So you have given the point A 43, B 22, C 83. You have given the point 43, 22, and 83. This is 43, 22, and 83, right? And this is what? T and T square. The area of the area of triangle ABC is 4 times the area of triangle PAB. Okay. area of triangle ABC is a 4 times of 4 times of the area PAB. 4 times of area PAB. Okay. So this is your question basically. So you have a triangle, this one. So see, if you have a triangle, this ABC, you can easily find the area of ABC, right? Right? Hello?
Yes, sir. Yes, sir.
You can easily find the area of ABC, whatever it is. Suppose it is somewhere around 48.
It's
Okay.
2. It's 2. Area of
Sir,
ABC
it's
is
2.
2.
You already find. How will you find? You have that nice formula, right?
Yeah, area
Okay,
we
suppose
have
this
got the
is 2.
formula.
Okay. What about this? This is 4 times of area of PAB. So what is it? Half. Then take x1 t, x2 minus x3. 4 minus 2 is 2. Right? Plus.
Sir, y2 minus y3 is
Oh,
that?
okay. Fine. Take y1. Let's see. A is your y1, x1, x2. Look, x1, y1, x2, y2, and x3, y3. So here, 1 by 2, 3 times 2 minus t. No, 2 minus 3, right?
2 minus
It's a
t
4.
square, sir.
It's a 4 into, I guess. 4 into because
What?
x
4
is
Okay.
into,
x is 4,
Okay.
sir.
here x is 4.
Okay. 4 into
2 minus t square
2 minus t square plus
plus
then
2
2
into
into
t square
t
minus
square
3.
minus t square minus 3. Then plus t into
Plus t into 3,
3 minus
sorry, 3
3
minus
minus
2
2.
minus
3 minus 2, which is 1. Right?
Yes,
So
sir.
this will cancel out by 2 times. So you have 2 is equals to 2 into 4 2s are 8 minus 4t square plus 2t square minus 6 plus what is this t. So this 2 will be cancelled out. So here you will get 1 is equals to 8 minus 6 is what? 2 now.
Yes, sir.
And
2
then
minus 2t
4t
square
minus 4t square plus 2t square is minus 2t square
minus 2t square plus t.
plus 2t. So here if you will, this will be like this. Just take it this side 2t square minus t and 1 minus 2 is minus 1. Now what else? You need to find the roots. If you will put a t is equals to 1 here, it will become 0. Right? So t is equals to 1 is one of your root, t minus 1 and then t minus 1 is equals to 0. Now t is equals to 1 is one of your root. So what we need? 2t here. So here it will be 2t square minus 2t, then plus 1. Then, okay, now fine. So you will get 2t plus 1, t minus 1 is equals to 0. Is it fine? Is it fine for everyone?
Yes, sir.
I just break it out. Like actually, basically, I found the value of t from here. I can easily found. You can use that like quadratic formula directly, or I have used here fraction. Okay, now what are the value of t? T is equals to minus half and 1. Now you got the value of t, right? You got the value of t. You can easily find this easily. For 2 distinct value, you will get distinct, like distinct triangle. Okay. Is there any information apart from that? What is the area of ABC? Area of ABC you can easily find, right? It's 2, as you said before. Okay. Now, is there any doubt up to? Is there any doubt?
No, sir.
Are you sure that
No,
the area of ABC is 2?
Yes, sir. We have solved it during the exam,
Yes,
so
sir.
we got 2.
Yes, sir. That's correct.
Yes, sir.
Okay, now fine. I don't think so. It's 2 basically. There is some
Sir,
mistake. Okay.
please go to the one note, please.
Okay. Yes. Did I make mistake in?
Yes, sir. Sir,
Yeah.
Yes, sir.
so
Factorization.
fifth last
Factorization
equation.
is wrong.
Sir,
This
Yes,
one.
sir.
area of triangle must be in mod.
Okay.
Hello.
But here T is unknown, no?
Yes, sir. That's why it is necessary.
Okay.
So
So if
1
I will put
equals
here
mod
mod.
of 2 minus 2t
Okay.
square.
So if I
Yes,
will
sir.
put mod here, so I will get two distinct value.
Yeah.
Here plus minus 1 will be
Yeah.
there, right?
So two distinct equation. Yeah. Two distinct quadratic equation. That will give the
Okay.
4 values of t.
Okay, fine. So here it will be this one is 1 and 2 minus 2t square plus t is equal. Sorry, I forgot that one. Okay, minus 1. Then it will be, you take
Yeah.
this thing here. So it will be 2t square, then minus t,
So
then it is
minus 1 or
minus
1?
3. From this, what are the values? Minus 1 and 1. If you will put here 1, so it will be 2 minus 1. No, minus 1, like 1 will not. Okay, minus 1 is the root.
So we have to apply Sridharacharya formula. Then we get the
Okay, we can
value of
directly
t.
put no t plus minus 1 is the root. No, if you will put a minus 1 here, what you will get? 2 minus plus 1. 2 plus 1 is 3. 3 minus 3 is 0.
Yeah.
2t.
Directly.
So it is around 2t square plus 2t. So what you need? 2t square plus 2t. But here you need minus. So minus 3. So minus 3t minus 3. Right, fine. So here you will get t is equals to 3 by 2 and t minus 1. Okay, so then your answer is, you got the answer, right? 4 points you will get. So
Yes.
your minus 1 point and 1 point. Other 2 point he did not mention. Okay, question is solved. It was not so tough, right?
Yes, sir.
Easy, no?
Yes, sir. It was easy.
What's the problem that you have faced? Can you please let me know? Like,
So after the equation, I couldn't solve after that. Like taking factorization, I got different answers, so I got confused because I got something like 3, as you mentioned that the p by q form I got. Then I confused, and in the options the p by q form is not given, so I was a bit confused what to do next.
okay. What about others?
No, sir. I got correct.
You got correct. Okay. Okay, then fine. Now, like, I have like in the revision session also, I have told you like that kind of question they can ask from this triangle formula.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. I was sure about the question, but like it's like everything I know, but like after the equation, I couldn't solve it.
Okay. Okay, fine. Let's start today's agenda. Okay, now it's okay. Okay, so basically the thing is like many of you guys, even they know the concept. The thing was like they were not able to solve that question in that particular situation. Like whatever they were facing in that, like in that pressure, you were not able to solve that question, right? Is that
Yes, sir.
was the issue?
Yeah,
Yeah,
that
that
was the
thing
issue.
is
Right, sir.
happens many times, right? That thing is happened many times. Like even I also faced that problem in my like in my IIT entrance exam. But yeah, for that till like you can give some mock tests and all night. If you are still facing that problem, you can give some mock tests. Like mock tests are also available on the it is available on your site, right?
Yes, it was there.
Yes, sir. That was
we have
Yeah,
very
so just
helpful.
just try to give the mock test. Like even if you have solved the mock test, just give again and again, so that it will be like it will be helpful for you. And then whenever you will give the mock test, just remember that you will give on the same time. Like if the exam is happening from 3 to 5. So you have to give that mock test on 3 to 5 only. Okay. Otherwise, you have practice on in the morning, you are giving, see, it won't affect that much, but it affects. It affects on the performance. Sometimes it happens that I am giving the exam and I am feeling sleepy right on that time. That thing it happens many times. So for that, whenever exams are coming, try to wake up on that particular time only. Don't sleep on that time duration. So that will also help you a lot. Also, like they will give some notepad and all, right?
Yes, sir,
Notepad.
they provide
Notepad
A4
kind of
sheets.
thing they will give for rough work, right?
Yeah,
Yes,
Yeah.
sir.
A4
A4
sheets they
sheet.
provide.
Yes.
A4 sheet.
Rough
A4
Yeah.
sheet.
Yes, sir.
Okay, so if they are giving A4 sheet, try to practice all the question by that A4 sheet only. See, this is all the small thing, but yeah, it affects a lot. Sometimes we will panic on those things, like, or one more thing, never use new pen on the examination hall. Okay, just try to like on that pen, they are not going to offer pen, right? Or they are offering you the pen in the examination hall.
No,
No,
sir.
just paper.
Yeah,
Or
you have to take
if
your
we ask
found
the
pen, right?
invigilator pen, then they provide us sometime, but they can't provide all
Okay,
the students. No, they can provide to
okay,
one or
okay,
two.
okay. So
Sir, for
don't
us, they
ask
are
for
not
pen to
allowing
them.
our pens, sir. For us, they are not allowing our own pens. They are giving on
Okay,
names
okay.
only.
Some center they will allow, some center they not. But yeah, if they are allowing your pen, please try to use those pen only. Like if you are used to of some pens, you just use that pen only. Okay, it will directly affect in your performance and all. If someone is JE student, they knows what are the things matters for the examination or. See, this is looking some silly things, but yeah, it affects. It affects a
Yeah,
lot.
it affects.
Right, sir.
Okay, let's start the session. So basically, we will start from the 1-1 function. Okay, so what is 1-1 function? Let me write the definition first. 1-1 function. Okay, I think most of you guys familiar for 1-1 function. Can someone tell me what is the definition of 1-1 function?
A function f of
Well,
x such that f of x1 is not equal to f of x2.
now,
Okay,
when
so
f of
basically,
X1 is not
x1
equal to
is equals to f of x2, then x1 should be equal to x2.
now
basically
both
the
can be
thing is
possible.
any function. Okay, any function, or we can say a function f is said to be a 1-to-1 function, or sometimes they will call injective function. Okay, 1-to-1 function. If for all x1 not equals to x2, your fx1 not equal to fx2. Okay, if this thing is happening for all the value of x and y, then we will say this function is 1-to-1 function. Okay, now
Sir,
let's do
sir, if
postmortem of this
f of
definition.
x1 is equal to f of x2.
Let's do postmortem of this of this definition. Yes, someone was asking something.
Sir, there
Hello.
can be a possibility of f of x1 is equal to f of x2.
Yeah.
Yeah, another definition is here. Another definition is saying,
x1 is equal to
or we can say if fx1 equal to fx2, then x1 must be equal to x2. Okay, this is the another definition. See, basically this definition and this definition both are same. This is just the negative negation of this particular statement. If x1 not equal to x2, then this happens. So I am saying
Yeah.
if this is not happen, then this should not happen. That's the thing.
So
Okay,
the
so
second statement, it does mean that it's not a 1-1 function, right?
this one. This is the definition of one function. You can use either this or this. This is basically saying whenever the two functional value are same, it means that the value is coming from the same value only.
Yeah, same
So
inputs
what does
map
it
to
mean?
same outputs.
What does it mean? That the thing is, it is saying whenever this, suppose this is your fx1 and fx2 both. So basically, if I am able to see, this is coming from two different values, right? It is x1 and x2. So this is saying whenever this kind of thing happens, basically this implies that this x1 and x2 both are not distinct. They are equal only. This is the thing. It means that this kind of thing will not happen at any cost if the function is 1, 1. Yeah, it will be available of us if the session will be on, you can find the session will be on YouTube. Okay. So understood the point, what it is saying? Basically, if this thing is happen, means that for a distinct x for a different x1 and x2, it means that if function is 1, 1, in that case, this x1 and x2 will be equal to each other only. Okay. Okay.
Yes, sir.
But
Yes,
say
sir.
it is
And
not one.
what this definition is saying, the above definition, our definition is saying, suppose your x1 and x2 both are distinct. He is initially assuming that the x1 and x2 both are distinct. Here, what we are assuming? We are assuming that the image of the function at a point is equal to image of a function at another point. Then in this case, we are saying that both of the point are equal to each other. They are not distinct. This is the second definition is saying. First definition saying that if x1 and x2 both are distinct point, then they will map to the distinct point only. Okay. See, both are the definition are shared exactly, but the thing is in the first in this definition we are going through this codomain part. Okay, we are seeing the value in codomain, and we are trying to relate the value from the domain part. And in this case, we are initially assuming the value of domain part, and we are trying to relate with this value from the output part. Okay. Yes, same inputs map to the same output. This is the one that's second and like second definition is saying. Exactly. It means that if two inputs are different, then you will get a different value. You will not going to get same value. Okay.
Excuse me, sir.
Yes.
Sir, why we cannot write like fx1 is not equal to fx2, then x1 is not equal to x2?
Okay, this is one doubt. Okay, I need that kind of doubt basically. So doubt is that why we are not trying, why we are not going with so what did you say? Can you repeat it again? fx1 not equal to fx2.
Yes, sir. Then x1 is
Then
not equal to
x2. This is your doubt, right? Like most of the person had that kind of doubt. Okay, why we are using this only? Why we are not using this? If fx1 not equal to fx2, then x1 not equal to x2. Okay, so this is what this definition is saying. This definition is saying whenever these two quantity are distinct, this quantity will be distinct. Okay, now I am saying what about assume this function fx is equals to x square. Okay. Okay.
Yes,
now
sir.
for any case, let's see the graph, how it will be. It is going like this, right? Right, Bhumika?
Yes, sir. Yes, sir.
Okay. So what you are saying, fx1 not equal to fx2. Okay. So it means that in this case, x1 square not equal to x2 square, right? Right.
Yes, sir. Yes, sir.
So what are the case? Either x1 square greater than x2 square, or other case x2 square is greater than x1 square, right?
Yes, sir.
Suppose first one is happening. And it is saying, sir, your x1 square is somewhere here, and your x2 square is somewhere here. Okay. So basically, if you will see the corresponding value of x, So this is your suppose okay. So this is your suppose x1 and this is your suppose x2, right? And this is your x2 square and this is your x1 square, right? That kind of thing will happen here, right?
Yes, sir.
So whenever you will take here x2 square is different. Okay, let's take an example. Suppose your like fx is 4 and another like here fx is 4, fx1 is 4 and fx2 is 9 in this case. Okay, so what are the things? What about x1 and x2? Your x1 should be 2 or you can say -2 and your fx2 should be -3 or 3, whatever it is, right? But in both case, what are the value you will take? You can easily see x1 not equal to x2, right?
Yes, sir.
Yes.
Right? It means that your first assumption, this is satisfying. Whenever you will take fx1 not equal to fx2, it means that x1 square not equal to x2 square. Your x1 and x2 both are not equal to each other, right?
Yes, sir.
So here this example is satisfying your this condition, right?
Yes, sir.
Right? So my question is whether this function is 1, 1 or does this function 1, 1?
Yes, sir, because it's have two distinct values.
No, it is not 1, 1.
Is not 1, 1. Why?
Not 1, 1, sir.
Because
So because
for this 4, as you can see, x1 is this 2 is also working, -2 is also working.
So
Right?
it is many to 1.
Yeah, it is many to 1. So it is not 1, 1. Okay, sir, but the question is, sir, but it is looking like this only, right? Looking like this. So why this definition is not working for 1, 1? So you got now this definition will not work for 1, 1. Bhumika,
yes, sir.
you got this?
Yes, sir.
This
Yes,
definition
sir.
will not work. But the question is why? Why this definition will not work? This is
Yes, sir.
still this question is coming in our mind, right? So basically, what this definition is saying? This definition is saying whenever this not equality sign is there, like in the input part, whenever this thing not equal to each other, then we will say x1 will not equal to each other. Okay, sir. But the thing is, what about this? Whenever fx1 equal to fx2, then what will you do? If fx1 equal to fx2, then what will you do? Whether this x1 equal to x2, this happens, or x1 cannot be equal to x2. This can be happen. Both are the possibility are open for this case, right?
Yes, sir.
For equality, both are the possibility open for this case. If this happen, then there is no such issue. But this can also happen like this case. If I will put fx is equals to 4, then I am getting 2x1 and x2. Both are different, but mapping to 4 only. Right? Right?
Yes, sir. Yes, sir.
Got the point? Why we are not using this idea? Okay, so this is question as well. Okay, don't use this. Either you can use this one or this one. Okay.
Okay, sir.
Okay,
Clear
sir.
to everyone?
Okay.
Yes, sir.
Is there any doubt here? Please ask. Okay. We are not
Sir,
in
if
hurry.
rather
Sir, I have a doubt regarding the registration.
Okay, regarding the registration doubt,
So can
please
you
ask
scroll
last
up?
in. Okay. Please, if you have general doubt, yeah, either you can you just ask in the beginning of the class or in the end of the class. Okay. In between the class, it's difficult for me. Otherwise, my mind will be lost. I am like my mind is very chanchal chanchal type of mind. Okay.
Okay.
It's
Okay.
very.
No, actually, I
I
was
will
just
think.
registering and I did not understand what should I do. There are I can register for 4 courses, so I am little bit confused in that. Should I choose 20 hour per week or 30 hour per week? So I'm in confused
It's
in this.
better if you will ask this thing to the TA because they know better about this kind of thing. Because I am not data science student now. I did not
Okay.
did this kind of course, so I don't have that much idea about it.
Okay, okay, sir.
I am just an instructor, so I don't
So
have
can you
that much
pause
idea,
there?
but still, yes, this one, right? Or
No,
which
to
one?
the statement where we cannot write the statement which is not
Caution part.
applicable.
Okay, don't worry. If you are writing, don't write. I will share this in the chat box in the end of the class. Okay.
I have a small doubt. The caution part
Yes.
I understood very well, but I think I
Okay.
missed a few points where we can actually use the proof.
You have these two definition you
I
can
missed it.
use.
I missed it. I didn't really. I know. I think my mind wandered off probably.
Okay, so basically the thing is a function f is said to be 1 if and only if whenever x1 and x2 both are distinct, okay, not equal to each other. Whenever you will take two distinct value in your input, you will get two distinct value in output.
This
it is not like you are taking this two distinct value and you are getting you are mapping in the same value. Okay, this thing will not happen. If function is 1 means that for two distinct value you are getting two distinct value in output.
Correct.
Okay.
Yeah.
Okay. It means that if you are putting your potato, you are getting two different kind of chips.
Okay.
So will you provide the link for this note, OneNote, to us?
I will download this OneNote like whatever this document is, and I will paste this document in the chat box itself.
Okay, sir. Today's session itself.
Yeah, this session itself.
Okay.
In the end of the class. Okay.
Okay.
Okay. Understood up to this?
Yes.
Okay.
Yes,
Now my question is. Okay, I am going in a very slow pace because you haven't seen the lecture, but still, please forgive me if someone has already watched the videos. Okay, the question is how the graph will be look like, how the graph will look for 1 function, or how we can make a 1 function graph, or we will say what kind of graph will give our 1 function. Okay.
Increasing or decreasing?
No, that's not I am talking about. What kind of graph we will get when the function is
Cubic, sir. What about cubic, sir?
cubic x cube. It's a 1 function. Okay.
Yeah.
We will discuss. Don't worry. When the function is 1 to 1. This is my question. 1. So what kind of graph we can get when the function is 1. Okay. This is my question. Okay. So what we are getting basically. What is our assumption? If I am getting this x1 and x2, the thing is, but for two distinct x1 and x2, either I will get this fx1. Okay, either you know now, for if you are taking two distinct value x1 and x2, your fx1 and fx2 both are not equal to each other, right? So pause vertical line test or horizontal line test. Yeah, I will explain this. Like I am coming into that only. Okay. Okay. So basically, if if I will put this two distinct value for 1 function, two distinct value, I will get this, right?
Yes, sir.
Right. Now, the thing is, yeah, if I am getting this, so there are two possibilities. What are those two possibilities? If two numbers are not equal to each other, then either fx1 is greater than fx2 or fx1 is less than fx2, right? If these two are the only possibility, then either this thing is happen or that thing is happen, right? This is the only possibility.
Yes, sir.
Or is there any possibility that are coming into your mind? Sir, after this, can you please explain how to solve 1-to-1 function? Yes, I will take some questions and then I will let you know. Okay. Don't worry. Just a minute. These are the two possibilities that are coming in your mind, right? If both things are not equal. Okay. Now, suppose that this one is happening. Okay, this was is happening. So your function will be somewhere here only, right? If this thing is happening, the second thing is happening, then your functional value will look like here only, right? Right?
Yes, sir.
Please answer. Okay. Now I am saying that suppose your function is like it's like that you are making this function like that. Okay. Suppose this is your functional value, this is your functional value, fx1 and fx2. And suppose here somewhere here x3 is there. So somewhere here you are getting fx3. So there are two doubts. See, whenever someone has told me like, sir, the graph will be increasing or decreasing, I will tell you that if function is 1, 1, it's not necessarily that the graph will be increasing or decreasing. Okay. I will explain these all the things in the differential part whenever you will discuss about differentiability and all. Then I will explain why this thing is not happening. So basically what I am saying here, you got this point, you got this point, you got this point. Still function is still function is 1, 1, right? If you have 2 points in domain, suppose your domain is like that. 1, 2, 3. This is your domain. And you are getting the value what? 2, 4, 6. Okay. F1 is 2, F2 is 4, F3 is 6. Okay.
Yes, sir.
See, try to understand the things. I am taking this kind of value. Still, this function is 1, 1.
Yes,
Yes,
sir.
sir. It is.
Right. In increasing, decreasing definition, you know, you have remember, right? I explained this thing on your revision session.
Yes, sir.
Yes,
Right. So basically, for increasing case, what are the definition? If x1 is greater than or equal to x2, then fx1 is greater than or equal to fx2. This is the case, right? For increasing case, right? This is the case, no? This is the case. Everyone has. If you have any doubts in this definition, please ask.
It's clear.
It's clear, right? Increasing, it means that whenever your input value will increase, simultaneously, according to that value, your functional value will increase. Right?
Okay.
Right? And what about decreasing? For decreasing case, if x1 is less than or same case we will take. If x1 is greater than or equal to fx2, x1 is greater than or equal to x2, then fx1 is less than or equal to x2. Right? What does it mean? For all x1 and x2. For all x1 and x2. So what does it mean? It means that the second definition, what does it mean for decreasing case? Whenever you will increase in the inputs value, your output value will decrease respectively, right?
Yes, sir.
Simultaneously, your output value will decrease according to your function, like input value, right? That is the definition of increasing. So basically, in increasing part, you are climbing like this. Whenever you will go like in this way, you will climb, and in decrease, you will fall like this, right? Right?
Yes, yes,
This is
yes,
the
sir.
thing. If someone is from Uttarakhand or that Pahadi areas, they will easily relate this thing. You got the point. You got the idea what is increasing, what is decreasing. Okay. So basically, someone has told me, sir, 1, 1 means increasing. They are somehow related. Okay, that thing is true. But my question is, if the function is 1, 1, then only this function will decrease or increase. Okay, so I will give you an example where function is 1, 1, but neither increasing nor decreasing. Okay. Okay, can you have any question? Like, can you have any example for that?
Constant function.
Constant function is not a one-one function.
But then it won't be
Okay. You need function which is one-one. You can define your domain and codomain according to you. Okay. Because function can be defined from any set to any set. Okay. Please.
So what about the line which is parallel to x-axis?
It's a constant.
That is constant function. No, that is constant function. And
So
that is not one-one.
y is equal to 0.
Y is equal to 0 is not. Y is equal to 0 is a horizontal line. No, x-axis only. This is that is constant function. That's what I'm saying. Constant function is not one-one function. I need an example of a one-one function which is neither increasing nor decreasing.
There's not.
Okay. Let's take this example. I have 1, 2, 3 in the domain and 2, 3, 4 in the codomain. And my F1 value is 3. My F2 value is 2. And my F4 value is 4. Sorry, F3 value is 4. Now, is this function increasing?
It first decreases and then it increases.
Okay. But this is not the not this this function neither increasing nor decreasing, right?
Yes.
Not a increasing function, not a decreasing function, right? In this domain, right? Are you able to see this function not increasing nor decreasing, right? But still, this is a one-one function because 1 is mapping to 3, 2 is mapping to 2, 3 is mapping to 4 only, right? Still, this is a one-one function.
Excuse me, sir.
Yes.
How you can say that it is not increasing or not decreasing? Because I think that from 3 to 2 it is decreasing, and then 2 to
But
4
I am talking about this entire domain. I am not splitting the domain. I am talking about entire domain because I already told you before. I already said you before. I can choose domain according to me. Okay, because function can be defined from anywhere to anywhere. Okay, any set to any set. So I can choose my domain according to me. So you can see in this domain the function is not increasing nor decreasing, right? Right, Bhumika?
I have a doubt here.
Yes.
See, maybe very
Yeah,
trivial.
it's okay. It's okay. It's okay.
Yeah.
It's okay.
Because it's 3 to 4, then it might take a waveform. And in that case, when we do that testing, that horizontal line testing, this might get.
I did not explain the horizontal line test
I know
yet.
that.
I
I
am
know
just
that. Yeah, that is why I said it might be trivial. But the problem is, will it be a one-to-one function in that case?
It's a one-to-one function. Suppose this is your 1, this is your 2, and this is your 3. So what you are getting basically for one case you are getting somewhere here 3.
Yeah,
For
3.
2 you are getting 2.
Then 4.
Somewhere here. For
Yeah.
3 you are getting 3. So this
Yeah,
kind of
4.
function you are getting. Only these 3 points. Okay. There are no connected line here. These 3 points only because you have only 1, 2, 3s in the domain.
Okay.
Just take any horizontal line.
I assume we have to connect the dots.
Why we have to connect? We have only these 3 points in the domain.
Oh, okay. Can function break like that? I mean, I'm just confused.
This is the function. This is the graph of the function. These 3 points only.
So it's not necessary that it should be connected.
Because function can be defined from anywhere to anywhere, any set to any set. Okay, it's not like the function can be connected. Have you seen this kind of function?
Yeah, we have
here you did not got the value. It means that this is not the function. This is not the case. Okay. Okay.
All right.
It can be point kind of thing.
All right.
As you have heard this point, right? You have seen this function fn is equals to n, where n is coming from your natural number. In this case, what you got? What you will get? You will get this, no? This case only 1 point here, second here, third here, like this. Because for f0 you got 0, f1 you got 1, So you are getting this distinct point. It means that this is not the function. This is the function, right?
Yeah, it is a
But
function.
in this
I
case,
assume that we will be connecting the dots, and so it will be a straight.
No. Not necessarily connected. Not necessarily connected. That is why we will learn in our future that continuity thing. That is why we will learn that continuity thing. Okay.
All right.
Okay, but till now we have only seen a function which is in U form, like in quadratic function or in polynomial function. So we are not aware of this discrete function.
The thing was when I was explaining all the definition of functions, I have taken this kind of discrete function only. Okay, I did not taken this kind of fx is equals to x square, kind like x cube, x plus 4, or e raised to the power x, a raised to the power x. Basically, whenever I was explaining something definition of function, so I was taking this a discrete function kind of thing only, right? So this is also a function.
Sir, what about the step function? In the graded assignment, they have given the step function, sir. Is it discrete or continuous, sir?
Step function is like this. Okay. Or some functions is looking like this. Fx is equals to, they define something here for something here. Okay, it depends on the functions. Okay, we cannot say it is a discrete or whatever it is. We cannot say like that. Okay, understood up to this? Is there any doubt you have? Please ask. If you have any doubt in this, please ask.
So can you differentiate between the discrete and continuous functions?
Yes, sir.
Discrete function. Okay, I will differentiate this thing on continuity part.
Because
okay,
it's not in syllabus.
I cannot do this thing in this class because continuity you didn't done right now, right? If you know the concept of continuity, you can easily make difference between these two. Basically, if you will ask me, so basically if points are not connected like this, here this point disconnected, this point disconnected, then you will see this kind of function is known as discrete function. Or basically discrete function is like if you have domain in discrete, domain is discrete, means that domain is like this point, not the exactly this interval you are taking, this interval you are taking, that thing is not happen, then we will say, yeah, it's not continuous function. Okay, I will explain this all the thing in continuity part. Okay. Okay.
Same terminology we are using in statistics.
Okay, discrete function. Most probably the thing like discrete function will be different there. Like, but yeah, I will explain this thing. Okay, discrete function and the continuous function. Okay, let's move further. Otherwise, we will stuck here only. Let's move further. Okay, so basically what you have seen here, you have seen that for increasing case, it is not necessarily that if function is 1, if function is function, then function is increasing or decreasing. Okay, we have seen this idea. This function neither increasing nor decreasing, but it's it's a 1 function, right?
Okay.
Right. Okay.
Yes.
Let's move further to the vertical line test or a horizontal line test. Basically, what we have seen, if we will if we will talk about this connected kind of function, it means that the graph should be connected like this or like this. Okay, these all the points you will get the value at all the points. Okay, remember this thing only right now. So that kind of connected graph thing. So basically, what you have seen that if function is 1, so the thing is if for 1 function you are getting this kind of thing, right? If x1 not equal to x2, then you are getting fx1 will not equal to fx2. So basically either this thing will happen. Where is the case? Okay, either this thing will happen or this thing will happen. Okay, it means that if both can be equal to each other, if both will be equal to each other, in that case the function will not be 1, right? What I am saying, basically, if for x1 not equal to x2, you will get fx1 equal to fx2. In this case, f is not 1, right? 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 Please answer.
Yes, sir.
If this thing has happened, then function is not 1.
Yeah, right.
It should be not
It means
equal to.
what? It means what?
One. It's not a
Suppose
1.
this is your x1, this is your x2, and in this case you will get same output. Suppose here is your fx1 and here is your fx2. Same output is means that this height should be same. This height should be same. Right? Right?
Yeah.
Yes, sir.
Right? It means that if you will join these two line, these 2 point by a line, this line should be parallel to the x-axis only.
Yeah.
Yes.
Right?
Yes.
Right?
Y value will be same for.
Yeah, y value will be same. So what is the observation here? The observation is that if your function is not 1, 1, then at least there exists a line which is parallel to x-axis, s-axis that cuts my graph into more than 2 points, right? More than 1 points, at least 2 points.
Yeah, yes, sir.
Right? Right?
Yes.
That is our observation, because we have seen that whenever x1 is not equal to x2, your fx1, if fx1 equal to fx2, in this case f is not 1, 1. So basically the thing is, if your horizontal line, or you will say a line parallel to x-axis, cuts your graph into more than 2 parts or more than 1 part, cuts more than 1 part, 1 point. Right? If function is not 1, 1, then there exists a line which is parallel to x-axis that cuts our graph into more than 1 points, right? Right?
Yes, sir.
Right? So this kind of test is known as. So basically someone has stand out and then he told me, sir, why we can't use this kind of thing? Like what we will do, we will make a graph of the function like this. Suppose this is your graph of the function, and we will draw a horizontal line or a line parallel to the x-axis. So what he said? He said we will draw a line parallel to x-axis, and then see in how many points does this line is cuts to my graph, right? This thing we can see now. We make a graph and we will draw the horizontal lines, and then we will see where this horizontal line is cutting our graph or not. Now, if this line cuts my graph into more than 2 points, then your function is not 1, 1, as we can see here, as we have seen here, right?
Yes, sir.
Right? So what we have to do, basically, we have to draw our graph, and then we will make horizontal lines which is parallel, or lines which is parallel to your x-axis, and then we have to see if there exists a line which cuts my graph in more than 2 points or more than 1 points. Then we will say this function is not 1, 1. Why? Because if this, see, in this case here it is cutting, here it is cutting. It means that both value are same, but in this case you are getting 2 distinct point, right? x1 and x2, not 1, 1.
Yes, sir.
Okay, so this test is known as horizontal line test. Or why it is known as horizontal line test? Because here you are testing your 1, 1 property with the help of horizontal line. Okay. Got the idea behind this horizontal line test? Is there any rocket science here? Is there any rocket science here?
No, sir. No.
All right. Easy.
Yes, sir.
Okay. So I am giving you an example of a function. say the function is x square plus 1, please let me know with the help of horizontal line test whether it is a 1 1 or on 2. Oh, sorry, 1 1 or not.
Not 100. Not 1.
Just try to make a graph of x square plus 1 and then try to check this is 1 1 or not.
Sir, it
How
is
will
1
it
to
look
1.
like?
It is 1 to 1.
It is 1 to 1. Let's see. Okay, when x is equals to 0, you will get fx is equals to 1. Right? When x is equals to 0, you will get fx is equals to 1.
No, it's not
Now,
1 1.
when x is equals to minus 1, what you will get? You will get 2.
Yes, sir. 2.
When x is equals to 1, you will get 2. So your graph will be look like this. Draw line. See, more than 2 parts. More than 1 part. Not 1 1.
Yeah.
Right? Understood how this horizontal line test work? Right?
Yes, sir.
Okay. So basically similar to this horizontal line test, there is one more. Okay. Again, my question is, can we say anything about ontoness here?
So we need to like we don't know about the codomain.
Suppose I have given codomain as R. This is your codomain. This is nice observation. We don't know about codomain. Now my codomain is R. Real numbers. Then
Not on to.
Not onto,
not
yeah,
on.
sir.
How will you check by horizontal line test for by our
Sir, not by horizontal line test.
Sir, below the graph, there is no cutting point for the.
Exactly. That's the observation. As you can see below the graph, there is no cutting point. So basically, if you will see, if you want to see this horizontal line by or the ontoness by horizontal line test, firstly recognize that what is your codomain. Okay. Then once you recognize the codomain, then make horizontal line test. Make horizontal lines parallel to make horizontal lines, and if you will able to find a zone where this line is not intersecting at any other anywhere of your graph. Okay, like this. Here there is no intersection with graph, right?
Yeah.
If you will able to find no
Okay, so
intersection zone in the codomain, then function is not on.
So that means for negative values, we are not getting any
Yes,
range, and
for
that's why
below one, this is your 1 point. Now for below 1 also you are not getting any
not getting
values.
the. Yes, sir. Yes, sir.
Right? So basically what you have to do for one case, if you have codomain, then you will say, sir, draw the horizontal lines and then see if you are getting a zone where the intersection of lines and graph is 0. There is no intersection. Then you will say, yeah, because if you will choose this point, there is no functional value, right? There is no
yeah,
x1 and
okay.
x2 for that you are getting the value.
We have to draw horizontal line where in our codomain range. In
Yeah,
the
in the
area of our
codomain.
Yeah.
Yeah, what are the
sir,
codomain is there? You have to draw the lines.
But sir, given that any quadratic function will have a maxima or a minima, and if the codomain is the entire scope of real numbers, then it will never be a onto function.
Yeah.
Right. because it has a maximum or a minima, so it will have
No, it
somewhere
has a,
at some point.
basically this thing is not work like that. See, in the quadratic function, you can say yes. But if you will talk about
Yes, I'm
normal
talking about quadratic function. I'm not talking
polynomial
about
function.
polynomials. Yes.
Yeah. So that thing will not happen in general. See, quadratic function is not onto in general. Okay, it's not onto. Because every time you will get some maxima and minima.
Right. And also it is not one-to-one because it always intersects on both the sides.
Yeah. No. You can't say like that because it depends on the domain as well. If I will restrict my domain up to this,
to half,
suppose I will take this is your domain, then what will you do? In this case, this will become one function because you are not talking about this side. You are only talking about this side. So this one-oneness is also depends on the domain as well. As I have shown here in this example, this discrete kind of example here, this function is 1, why? Because I have taken this discrete domain, right? Suppose in this case, if I will take this entire thing and the function is connected, so it will look like this or somewhere look like this only. So in this case, it can't be 1. Right? So it depends. It's basically depends on the domain. Okay. There are so many factors which is depend like which will affect our on one-oneness or on-two-ness. Got the idea
Sir,
basically? Yes.
Sir, if discriminant of a quadratic function is 0, then it becoming 1.
What does it mean? If your discriminant is 0, it means what?
That means function will be the same.
You will get two same roots. This is the only thing that you can say.
Yeah, for f of x1 is equal to f of x2, x1 is equal to x2.
This is also a example of a quadratic function for which the discriminant is 0. Not 1, not 1. See, if you will see any quadratic function and you will see the largest domain for that function, it won't be 1, won't be on 2. Okay. Okay.
So we can say that quadratic functions are never 1-to-1.
Yes, in the largest domain. Okay, largest domain of definition, not 1. Largest domain of definition, it means that we will take the largest set where the function is defined. And it for quadratic function, it's your real number only. It's your set of real numbers. Okay, so I understood up to this. And any doubt?
Yes, if a quadratic function has equal roots, can it be 1-to-1?
No.
Yeah, that is same doubt I mean.
If you have equal roots, what does it mean equal roots?
For f of x1 is equal to f of x2,
this is
x1 is
only
equal to
now.
x square.
This is only equal roots mean that you are you have right. Suppose x1 and x2 both are roots of your quadratic function fx, then x1 and x2 both are equal to each other, right? This is the roots, equal roots thing, right?
Yes.
If you will take this function, this also have equal roots, x minus 1, or you will see x square. X square also has equal root. 0 is the only root it has, right?
Yes.
But does this function 1? This is the x square graph.
No.
No,
point,
sir.
not 1.
Yeah, got it.
Got the idea? Okay,
Yeah, yes,
so
sir.
let's move. So similar, see, same, since this is a horizontal line test, so you got the idea about horizontal lines. One more test is here, known as vertical line test. Okay, how this vertical line test will helpful for us? So basically, this test will be used to checking whether the given curve is a graph of the function or not. Okay, vertical line test is saying basically draw the lines which is parallel to y-axis. Okay, suppose this is your graph. Okay, and you have to draw the line parallel to y-axis. So if this is a function, then this line should cut your graph in exactly at one point, right? In the domain of definition. Okay. Basically, You have to draw the line. If you have a graph like this, suppose this is the graph. Okay, and your domain of definition is greater than or equal to 0. X is this is defined from greater than x is greater than or equal to 0. What I am saying, please draw the lines which is like parallel to y-axis. And as you can see here, you are these lines are cutting this graph into two parts, like into 2 points, right? There is 2 intersection for each lines, right?
Yes, sir.
What does it mean? It means that this is your point x0, and this x0 you are getting 2 distinct value, right?
Yes, sir.
This is your x0, and this x0 is mapping f1 x0 and fx0 prime, right? That thing is happening now. Here, this is mapping to here and here on all, like, right? For one x0, you are getting 2 distinct value, right?
One input, 2 output. One to many.
Right? 2 distinct output, right?
Yes, sir.
Not function. Not a function. Not a function.
Yes, sir.
So basically, why we will use this vertical line test. So if you have a graph and the question is asking whether the given graph is function or not. So what you need to do?
Vertical
if you
line
have the domain of definition, then just draw the lines parallel to the y-axis and then see if this lines cutting to your graph more than 1 point or not any point. Suppose if you will include all the real line, or as you can see here, this line is not cutting anywhere. So still what you are getting? You are getting the values like negative values for which you are not getting any points in this, for which you are not getting any images in your domain set. Right? Here these are the value which are left. For that you are not getting any values here. It means that this is not the function at both case, right?
Sorry, sir, can you repeat this line again?
What I am saying, suppose you have a graph like this. So if you have to check whether this graph is a function or not, what you need to check? You just draw the vertical lines. Okay. And then see at how many points these lines are cutting to your graph. Now, as you can see, if you will consider the domain entirely, you can see here, if you will see these are the lines, these lines are not cutting your graph at any point.
Yeah.
Right? So if you will take, suppose you have chosen this -1 here. So you are not getting any value for this -1, right? There is no such value in your codomain for which this -1 is mapped.
Yeah.
No values in this in the codomain because your function is defined here only. You are not getting any value here. There is no assigned value for this function. Not a function. Because in the definition of the function, what we will say? Each points here will get a unique image, right? Will get an image. Each point will get an image, and that image will be not equal to, like, the image will be unique, right? This is the point. This is the definition of function. But here 2 things are happening. Even if we will restrict our domain, as you can see, if I will talk about this line, so for this line here, if you will consider x0, so for this x0, you are getting two values in your graph. It means that this is not the function. What does it mean? It means that here is your x0 and this x0 is mapping to distinct value. So in this case, this is not the function because this x0 can map only one value if it is a function. So basically, if your domain of definition is given to you, and the question is, they have given a graph to you, and they will say, just recognize that whether this given function is a graph of a function or not. Okay, given curve is a graph of the function or not. So what you need to check? You need to draw this vertical line and then check whether this vertical line cutting your graph exactly at 1 point or not. If it is not cutting your graph exactly at 1 point, then you will say this is not a function. exactly at one point, it means that it has to be cut only on one point only. If it is cutting more than one, or if it is not cutting your graph, not a function. Got the idea?
Okay, so for onto in horizontal line test, we have to draw the line on our codomain. And
Yes.
for in vertical line test, to check if it is a function or not, we have to draw the line in our range of domain.
Domain. Yes, exactly. Nice observation. Okay. Got the idea? Now got the
Yes.
idea? Okay. Okay. So, okay. Here. So I have explained this increasing and decreasing part. Let us go through the more general for this increasing and decreasing. So basically, increasing and decreasing function. Let me write the definition again. Increasing and decreasing function. Increasing function. Okay, so here I will use two terminology. One is increasing function, another one is strictly increasing function. Both are different, okay? I will use increasing function and strictly increasing function. Two terminology. Though in the lecture slide, they like there did not mention that increasing and strictly increasing separately, but here I will include both of the things, increasing and decreasing separately. Okay. Okay.
Yes.
So
Yes, sir.
I am not explaining whole things for increasing function because I have already covered this thing. So basically a function f is said to be increasing if and only if for all x1 and x2 such that x1 is greater than or equal to x2, your x1 fx1 is greater than or equal to fx2. For example, take fx is equals to x cube. Okay, so in this case, whenever you will take this x1 is greater than or equal to x2, your fx1 will be greater than fx2. Okay, because x1 cube will be greater than or equal to x2. Okay, easy? Easy, right?
So you've written equal to.
Yeah, so greater than or equal to. Okay, easy? Sir, can we say a linear function is always onto if it is not parallel to x-axis? Yes. Or y-axis. If it is parallel to y-axis, it will not become a function. Okay. If it is parallel to y-axis, then it will not become a function. Why? Because you have this graph. Parallel to y-axis, it means this. For this only point, you are getting infinitely many outcomes. Not a function.
Based on that observation.
Yes. Okay. So you got this increasing function definition, right? No, nothing is thing is for explaining here. I have already explained so many things. Now I will talk about strictly increasing. What is this strictly increasing? So basically, if I will remove this equality sign from here, both sides. Okay, if I will remove equality sign here from both sides, then we will say this is the definition of increasing function. Let's see. F is said to be strictly increasing if for x1 is greater than x2, your fx1 is strictly greater than fx2. Okay, if you will take two distinct points like this, then your fx1 and fx2 will behave like this for all x1 and x2. Okay. So the question is, what are the difference between these two definitions? Basically, here I am using equality sign here, but here I am not using equality sign. So in this case, if you will take fx is equals to some force, this is a constant function. This function is still be known
Sir,
as
your voice is
increasing function.
breaking.
Why it is known as increasing function? Because of this equality sign. Because of this equality sign. Okay. What does it is equality less than, like what does this greater than or equal to means? It means that either x1 is greater than x2 or it is equal to x2. Right? If one of the condition holds, either this or this, then this sign we can use, right? So for this case, always this equality is satisfying this equality part. So we can say for x1 is greater than or equal to x2, your fx1 is always greater than or equal to fx2. Means 4 is greater than or equal to 4. We can write this because either the first condition this happens or this happens. I know this is incorrect, but this happens always. It means that we can use this sign for that. Right? Right? So this is also an increasing function. Right?
Yes, sir.
Right? Because of the definition of increasing function, this is also an increasing function, right? But what
Sir,
about
please, can you repeat?
what I am saying? What does this equality means? This equality means if I will use, suppose I am saying there is two numbers, say x1 and x2, and this number are like comparing like this sign, like x1 is greater than or equal to x2. What does it mean? It means that either, sir, x1 is greater than x2 or x1 is equals to x2. This is the two possibility for that, right?
Yeah. So in this case, even if x1 will be equal to x2, then we'll consider it as an increasing function.
Yes. Even if x1 and x2 both are equal to each other, we can use this sign, right? Because this sign allowed me for these two conditions. If any one of them is satisfying, we will take this sign, right?
Yes.
We will say that yeah, this one is greater than or equal to this two. So basically, if I will take this fx is equals to 4 as constant function, then if I will take any x1 and x2 which are not equal to each other, x2, you will always get this fx1 greater than or equal to fx2, right? Because 4 is always greater than or equals to 4,
Yes.
right?
Yes.
Because of this equality. Okay,
Yeah,
but
so
what
it would
about
be
this
considered
strictly
as,
increase?
yeah, so it would be
Yes.
considered as increasing function.
Yes, but it's not 1, right?
Yeah, it's not 1.
So what is the observation here? Increasing function is not necessarily 1 function. Got the idea? That's what I want to explain.
Yes.
Okay.
So basically, please, many of you guys will argue like in the PDF, like in the lectures, they have mentioned that increasing function is a 1 function, but there is a correction that I am using this strictly increasing term. That is why I am using this strictly increasing term here. Okay. Just go through by this definition. You got the idea? Every increasing function is not necessarily a 1 function.
Yes.
Yes. Because I have seen this, we have seen this counter example. Okay. Now, what about strictly increasing function? Strictly increasing, it means that what? x1, if x1 is greater than x2, then it is saying fx1 is greater than fx2. Right? Right?
Yes, sir.
Right?
Yes.
What does it mean? What does it mean? It means that here I am taking two distinct value, right? Right?
Yes, sir.
For two distinct value, x1 and x2, because x1 is greater than x2, what does it mean? Both are not equal to each other. Right? It means that for x1 not equal to x2, you are always getting this kind of thing, right?
Yes.
Because for this case, this fx1 is strictly greater than fx2. Suppose how I am saying this is 1 function. So I am saying take any two distinct point. Any two distinct points. Suppose x and y you have taken. Okay. For instance, I will take what I will take. Okay, suppose I am taking L1 and L2 to distinct point in your domain. Okay, what is the domain that you have defined for F? I am taking to distinct point. Distinct point, it means that L1 is not equal to L2. So in real life, only two possibility, right? Only two possibility. Either L1 is greater than L2 or L2 is greater than L1. Right? Only two possibility here. Right?
Yes,
Right? right?
Yes, sir.
It
Yes.
means that if this
Yes, sir.
this
Yeah.
happen, then FL1 is greater than FL2 because F is increasing, and for this FL2 is greater than FL1, right? Right?
Yeah,
If
understood.
one of the condition will hold, so
Yeah.
according to that condition, this kind of thing will happen. So it means that for both of the case, FL1 is not equal to FL2 for any L1 and L2, which are not equal to each other. It means that F is your 1, 1 now.
Yeah.
So basically, what is the result? If function F is strictly increasing, then F is 1, 2, 1. Got the idea? Why we are using this strictly increasing part,
Excuse
right?
me,
And
sir.
why it is 1, 2, 1 for strictly increasing case? Got the idea?
Yes, sir.
Yes, sir.
Got it? Is there any doubt? Please ask. Similarly, can you define for decreasing? Similarly, can you please define for decreasing case? Same thing is there. So this is your exercise. Do this.
So figuratively, if we don't use that equal to sign in between two, what do you call it, two x values, then it is strictly. You mean we have to
Yes.
assume that that is strictly.
Yes.
Okay.
Because here we are not using that strictly sign, like equality sign.
Yeah. So
basically we are discarding all the value for that equality thing we have discard. Okay. So
okay.
basically this function will be like this only. This will be like
Yeah. Understood.
you have to climb only. Right? There
Yeah.
is no rest point like this.
Okay. Okay.
You have
Understood.
to just climb on.
Yeah.
Excuse me,
Okay.
sir.
Yes.
So as you mentioned that in lectures it is given that increasing functions are 1, 2, 1. So like if in exam it will come, so what we have to write? It is 1, 2, 1
You
or
have to go by this kind of thing. Okay. Whatever I have explained today, you just go by this thing because that definition is a bit confusing. Because this increasing and strictly increasing part thing is like other authors define by their own way. Some are using increasing for this strictly thing only. Okay. So basically, it depends on the author by author. So that is why I'm saying just
so
go with the definition. The doubt will be clear to you, right? You will not going to confuse at any point.
so sir in exam if the question is asked like increasing function is
Yeah.
1, 2, 1, so we have to write no.
Yes, exactly. That is incorrect. Okay. That is incorrect.
Okay.
Yes, there in our activity questions also in the dashboard. So there the question is which of the following statements are true, and the option is given correct marks for if f is an increasing function then f is 1, 2, 1. It is a correct answer there.
Okay, so you can argue for that question. Wherever the question will solve, you can argue for that. And you will give the like whatever example I have given, you can just give you that example. See, there is a possibility that some questions are maybe incorrect, right? Because human being all has created that question. Human error can be possible. So you can directly argue for that. Okay, if you are getting this kind of thing, you just do an example and argue for that, sir. We are getting this example. This is also certifying the increasing condition, but it is not a 1, 1 function. You can give that kind of example. Okay.
Okay, sir. Thank you.
You will get marks for that. Don't worry.
Okay, sir.
Got the idea? So this is your exercise. Do this for decreasing function. Okay. Now let's move forward for example of 1, 1 function. 1, 2, 1 function. Okay. So basically your first example is fx is equals to x. This is also your 1, 1 function x cube. Any equation of line very not equal to 0. Okay, these are the example for 1, 1 function. Okay. Now, one more example is there known as fx is equals to a raised to the power x. Okay, why this is 1 function? So let's see why this is 1 function. Okay, basically my question is whether this function is defined or not, whether this is a function or not. I am defining a function like a raised to the power x. I am defining something, I am not saying this is a function. I am defining something, and my question is whether whatever thing we have defined, this f is a function or not. Okay. 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 This answer.
So,
Okay, sir.
Yes.
can we say
Yes, sir.
I have a doubt, sir.
I haven't give any name for this. Many of you know about this. This is known as exponential function. But till now, I defined this function. After that, we will see this is an example of 1 function. Okay. After that, we will see this is an example of 1 function. But till now, I have discussed here only.
So what
This
is
thing
x
only.
here?
So,
Yes.
can we say
X,
one?
your
Hello?
input value. X is
Like
your
all
input
Yeah.
real
value.
values.
A belongs to R. A belongs to R. Any constant. Right now, I am taking A belongs to R. Okay, any constant. And X is your R, like input value.
So
Right now, I am taking. We have to see for what value of A this is defined. Okay.
Yeah.
So if F is not function, if it is a function, then no issue. And I don't have any problem. If it is not a function, then my question is, then for what value of f, what value of a and x, f will become a function. Right? These are the two questions that are coming into my mind whenever I am seeing this kind of expression. Right? First one is whether this kind of expression is a function or not. If it is not a function, so for what value of a and x, this will become a function. Right? Because this whole thing will depends on the value of a and x only. Right? So my question is whether this thing is a function or
It is
not.
not a function.
Not a function. Why?
Because A can take negative value as well as positive value, and
Yes. So if I will take A is equals to 0, suppose A is equals to 0, then what will be my function? Can someone tell me if A is equals to 0, then what will be my function?
Value you want.
not defined.
no,
Equals
Not
zero.
defined.
power of x.
Oh, sorry.
Not defined because your x is coming from R. Right? Your x is coming from R. So why it is not defined? Suppose x is equals to 0. What will you do? Because 0 raised to the power 0 is not defined. So if you have to define this x for all real value, you cannot take A is equals to 0. Right?
Yeah.
Right? Okay. What about the negative value of A? Suppose A is equals to -1, then?
See, in case of -1, if x is even, then it won't be a function. If it is odd,
And
No, if
if
it
it
is
is,
negative, then the square root will not be possible.
no, yeah, it will be a
Half will not
complex
be possible.
number.
Yes. If you will put x is equals to 1/2, again not defined. If we will working in R only, not defined.
Hmm.
Getting my point? It means that for that, if we are defining fx is equals to a raised to the power x and we are taking all the values from R, what is your condition? Your condition is a has to be strictly greater than 0. Right? Right? If we have to define this f as a function, your a should have to be strictly greater than 0.
Yeah.
Okay. What about this x? This x can be any real number. Let's take about if x is in the form of p by q, then what will happen? We can easily make, if you have a given number a is equals to suppose 2 and p by q, suppose p by q is equals 3 by 2, you can easily find the value of 2 raised to the power 3 by 2, right? It is what? 2 raised to the power 3, then its square root. What is it? 8 raised to the power 1 by 2, which is 2 root 2.
2 square root.
Again, it's a real number, right? Real number means that we can take any irrational number, any rational number as your x input, right? Right?
Okay.
Please answer.
Yes, yeah.
You can take any irrational number because you can define like this. If you will take if you will fix your a, then for that you can define like this, right? Any irrational number, you will get the value.
Right.
No issue. You will not get any complex value and not defined kind of thing. You will always get a real number. Got the idea?
Yeah.
What about when x is equals to irrational? Suppose x is equals to pi here. What is the value of pi? 3.14. 159 something, right? And if your a is equals to 2, then what about your fx? Fx is your 2 raised to the power x. So you are taking x is equals to pi. So if you will see this 3.14 at x is equals to 14, then you will see 3.145, then 141, then 2 raised to the power 1.1415. Basically, firstly, I have taken 3.1, 3.0, then 3.1, then 3.14, then 3.141, then 3.145, then 3.1459. So basically, what I am trying to see, basically, if you will see this number, so since the above number, the like the exponent part or whatever part is there in the power, it is going towards pi, right?
Yeah.
Right. So basically, if the power part is going towards pi, so whole thing, whatever this are there, this will go towards 2 raised to the power pi. Right. So basically, this is also defined. If this thing is happen, this thing is happen, this is also a real number. No issue. Right? Because if this is your pi, so 2 raised to the power, if you will see here, somewhere here it will be. Because this is going towards there, right? All the things is exist, all things are exist, right?
Yeah.
Right? So all the things are exist, it means that it will be a real number. So what does it mean? Yes. So if I will define this fx is equals to a raised to the power x, so there is only condition on your a. It is greater than 0, x can be coming from r. Okay. So from here, for this kind of value, I know that this will become your function. Okay. Understood up to this?
Yeah.
Okay. So basically, this below part known as base in this case, and the above part is known as exponent. Exponent. Okay. Is spelling just checked. And the whole function, this whole function is known as exponential function. Got the idea?
Yes, sir.
Got the idea? Okay. Because of this exponent, exponent, we will talk about it. See, here we are saying, here we are just talking about where the function is not defined. Okay. We will let you know what about when x is equal to 1. Okay. So basically what we will say? We will say this function is known as exponential function. Why it is known as exponential function? Because for a fixed value of a, suppose you have taken a is equals to 2. Whenever you will define your function fx, it will become your 2 raised to the power x. So whenever x is growing towards infinity, this function will grow exponentially, right? Suppose for x is equals to 1, you get value 2. For x equals to 2, you are getting a 2 raised to the power 2. 3, 2 raised to the power 3, 4, 2 raised to the power 4. So what you are getting? This this function will go in power of 2, right? Right? Here 2 power is increasing, right? It is going with the help of powers. And powers, this power is known as exponent. That is why we are saying this is a exponential function. And the growth of that kind of function is known as exponential growth of a function. Exponential growth. Okay. Okay. And this is very khatarnak kind of function. Why it is khatarnak? Have you heard that that story where there was like in ancient time there was a king and a Brahman helped for something. I don't know what are the reason. For like he helped a king for any other topic, and the king was very happy about his work. So king offered that you just ask whatever you want. So Brahman was like, yeah. So Brahman means, if you will see in the new era, so Brahman means PhD scholar or a professor, you can say. Brahman, it means that a very like a very intelligent person. So, okay. So he resolved some problems for a king. Okay, he do some work for that. King was very happy for that work. So he was just said to the Brahman. He was like, just ask whatever you want. I will do that kind of thing. So the Brahman was like, no, I don't need anything. So the king, when the king was like, yeah, you have to ask something. You have to ask for something. So the Brahman is like, just go through the chess board. And as you can see, there are 64 boxes. So just put like a piece of grain and just put in each box and just double it. So in first box you will get 1, another box you will get 2, then 4, then 8, then 16, that kind of thing. Basically here you was talking about in 2 raised to the power n case. Okay, so for n is equals to 0, you got this one part, one piece of grain. For n is equals to 2, you got, n is equals to 1, you got for 2 piece of grain. So after certain points, whatever the minister was there, they were like, Maharaj, we are not able to fulfill this demand because after some certain step, we don't have anything to do. Like after the certain step, we lose all of the whatever grain we have. Right? So basically, this is a very khatarnak, very powerful function. Okay. After certain effect, it will grow rapidly. Rapidly go through the infinity. You're getting the idea?
Yes, sir.
Can we
Yes,
say
sir.
that exponential
I heard
function
this
is
story.
always
Yeah,
increasing?
I also heard this.
Sorry?
Can we say that exponential function is always increasing function?
We will see. We will see now. We will see. Firstly, we have defined this kind of thing. Okay. See, we are saying this exponential function because the growth is going rapidly, right? The growth is too much here.
Yeah.
Okay. Now, what about a is equals to 1? If I will put a is equals to 1, then your function will be like, so what are the value of x you will take? Your function will be 1 only. Is there any growth in this function? This is just a constant function. No, right? No growth.
No.
So
No.
we will say, if we will talk about exponential function, see here since this function is still defined for a is equals to 1, but here we are including this exponential function term because there is no such exponential growth of this function, then we will not consider for a is equal to 1 as exponential function. Okay, so this is not an exponential function. So if we will talk about exponential function, so exponential function, let me write the definition. exponential function. So a function of the form.
Sir, one question, please.
Yes. Yes, ask.
Sir, for the function 1 to the power x, then
1 to the power
we
x.
find the 1 to the power infinity is not defined. The value 1 to the power infinity.
Okay, you are saying like this. My question is x equals to infinity is defined? Whether this infinity is a real number?
No, sir.
No, right? So if it is not a real number, why we are talking about 1 raised to the power infinity is nothing. Like it's just a conceptual thing. Infinity is not a real number, not a complex number. It's just a conceptual thing. Okay, just for representing purpose.
Sir,
Yes.
sir, can you please repeat for why a is not equal to 1?
See, if a is equals to 1, this will become constant function, right? And we have, we gave this function x1, we give this name exponential only because of the exponential growth that we are seeing here. But in the case of a is equals to 1, we are not able to see any exponential growth. This is just a constant function. So this for a is equals to 1, we will not consider this function as a exponential function. But still, it is still a function, but not an exponential function because it does not have any exponential growth. Okay.
Yes, sir.
Yes, sir.
Okay.
So can you please provide this PDF? It's 10 p.m. and I have to go.
Yeah, okay. I will go. It's 10 p.m. Okay. We have this. Okay, it's like we don't have that. No, not much to complete. Most probably by 11 it will be complete. Okay, exponential thing is almost done. Okay, we will talk about the domain. See, we have defined a function. Okay, now let's discuss about domain. Domain of exponential function f. Okay, what is the domain? Is there any problem in this x for taking the values? No, right? X can take any value from real number.
Yeah.
Yes.
Okay, so the domain of f is nothing but your real number only. Right?
Yeah.
What about the range of f?
Should be a real number as well.
Sorry?
Should be a real number as well.
It will be real number, yeah. That thing we know, but what it will be? Let's see what it will be. For a is to the power x. So let's take an example for a is equals to 2. For a is equals to 2, it is 2 raised to the power x. Okay. It is
it will be
okay.
positive
So whether
number.
Yeah, it is positive number. Why it is? Let's see. Okay. What about when x goes to infinity? When x goes to infinity to 2 raised to the power x, whole thing will go to infinity only.
Yes.
Right? What about when x is equals to 0?
1.
It is 1. Okay. What about when x goes to minus infinity?
It will be some fraction.
Negative.
Okay. It is go to minus infinity. It means that after some time it will be the x will be negative, right? It has to be negative after some time.
Negative.
It means that 1 raised to the power 2 something mod x kind of thing will be there. Right? Right? If x is negative, if something is negative, minus 1, suppose 2 raised to the power minus 1, what does it mean? 2 raised to the power mod 1, na? Right? The positive will be go inside. Okay, so basically, if x goes to minus infinity, it means that mod x goes to infinity. If mod x goes to infinity, it means that this whole term will go to infinity. If denominator part is going towards infinity, the whole thing will go to 0. Right? Right? Means that fx goes to 0 if x goes to minus infinity. Let's see whether this function is a like whether this function is a increasing or decreasing. Let's take x1 is greater than or equal to x2. What about fx1 and fx2? Support is not the increasing function. Then for at least one x1 and x2, this thing will happen, right? fx1 and fx2 is equal to each other if it is not a 1 1, not 1 1, not increasing. So not 1 1. Let's take a 1 1 case. Okay, then we will see for increasing case. Or let's talk about the distinct thing. Okay, if x1 is greater than or equal to x2, it means that x1 minus x2 is greater than or equal to x0, right? Right?
Yeah. Right.
Okay. But so we have seen for the positive case, if x1 is greater than or equal to x2, then we have seen that f of x1 minus f of x2 is greater than or equal to 0. Right? Because as you can see, for n is equals to 1, you are getting 2 raised to the power of 1. N is equals to 2, you are getting 2 raised to the power 2. N is equals to 3, you are getting 2 raised to the power 3. So whenever n is greater, n is positive, you are getting in the increasing order. This thing will be positive only, right?
Yeah. Yeah.
Right? Right? So basically, 2 raised to the power x1 minus x2 is greater than or equal to 0. Or it is greater than or equal to 2 raised to the power 0. Sorry. Right?
Yeah.
If 0 is there, 0 is greater than or equal to 1. So basically it is greater than or equal to 2 raised to the power 0, right? Right?
Yeah.
Yes, sir.
So basically what it would be? 2 raised to the power x1 by 2 raised to the power x2 greater than or equal to 1. Basically 2 raised to the power x1 is greater than or equal to 2 raised to the power x2. Increasing function? Increasing, right?
Yeah.
And if I will exclude this equality sign, then also it is true. No constant kind of thing is there here, right? Right?
One question, sir. If it is greater than or equal to, or is it greater than?
If you will, like here, I am using equality sign, but if I will exclude this equality sign here, then also it is true.
Yeah, it will
For
be true, but
exponential case, there is
correct. But
true.
if greater than or equal to, at some point x1 will be equal to x2, right?
Yes, that is why here I have used this equality sign. If I will exclude this equality sign from here, so all the equality sign will be excluded.
Okay.
That's what I am saying. Okay, so basically this function is strictly increasing function, right?
Yeah.
Right. So for x, a is equals to 2, what does it mean? It means that the graph will be look like this, right? Here as x goes to minus infinity, it is going towards 0. X equals to 0, it is 1. X is equals to infinity is going like this, right? Got the idea?
Yeah.
So this is graph of 2 raised to the power x. Okay. What about when a is greater than 1? The graph will be look like this only. Right? For a is greater than 1, it means that for x is equals to 0, a is equals to, sorry, this is 1. As x goes to minus infinity. Sir, can you share this PDF in the discourse? I don't have discourse. I will share here only. I can share here only. Okay. You can go, Suraj. I am requesting with someone. Please, if you are able to attach this file on the YouTube comment box, you just go and attach this file on the YouTube comment box. Okay. Anyone who will be there in this class. Okay, it's okay. It's okay. It's okay. Anyone, please do this thing. Okay, or either you can message me on this. In this email. Okay, do message on chat box, like via chat. Okay, don't email me. Otherwise, I have not used to seeing the email of study mail because my
Okay, sir.
phone is
Thank
not
you, sir.
working well right now. Not working well right now. If you will drop me an email, email will not coming to my phone. If you will message me on via chat box, I will that it will directly pop up as a notification. So I will be easily see that one.
Okay, sir.
Okay, just tell me. Just message me on this ID. I will give you the PDF. Okay, so you have seen that for a is greater than 1, there is no such issue. Okay, as x goes to infinity, this a raised to the power x goes to infinity. So graph will be is only. Okay, what about if a is less than 1 and greater than 0? Suppose a is equals to 1 by 2 you have chosen. So a raised to the power x is look like this, right? Okay, so in this case, if you will talk about the range of this function, so the range of this function is 0 to infinity only, right? 0 is also not included, right?
The range will take negative also, no?
Why? Because the graph is above the x-axis only. Here only positive value you will take. Negative value, it means that are you taking any intersection here?
Okay, sorry, sir. Sorry, sir.
No, right? So 0 to infinity is the range. Okay, so for a is equal to 1 by 2 in this case, what will happen? So if again for x is equals to 0, you will get fx is equals to 0, fx is equals to 1, right? F0 is equals to 1, right?
Yeah.
Good night, good night. Okay, for x goes to infinity, it means that the denominator part will go to infinity, right?
Yes.
Right? Mean that a raised to the power x goes to what?
0.
0. For x goes to infinity. Here, this thing is totally opposite to this thing. Here, as x goes to infinity, this is going towards infinity. But in this case, this is going towards 0. Right? Right? Okay. As x goes to minus infinity, then then after certain point, the x should be negative. So in this case, you can write it as 2 raised to the power mod x, right? Right? If you have minus 2 here, what you can write? You can write 1 upon 2 raised to the power 2, right? Or it is what? 2 raised to the power 2 only. So this is basically what? 2 raised to the power mod of minus 2. Right?
Yeah.
Absolute value of, right? So basically what you will see, as x goes to infinity, this whole thing will go to, sorry, minus infinity, this whole thing will go to infinity, right? And since this is the, now in this case, this will become a decreasing function. Okay, same argument you can check. By same argument, you can check. Okay, this is your exercise. One more exercise for you. Check for a is less than 1. Fx is equals to a raised to the power x is strictly decreasing. Now, if it is strictly decreasing, you got this. So the graph will be look like this. Okay. Okay. Now, exponent function is clear to everyone right now.
Yes.
Okay. So right now I am not taking like all of the example basically because it's difficult for me. So yeah, most probably if we will discuss week 5 in the Friday's class. So I will take that out. Or see, if you like tomorrow, if there will be class tomorrow for week 5, just tell whoever the instructor will come for tomorrow, just tell them, please explain via exam, explain the examples for this week 5, because I will cover all the things, all the conceptual part today itself. Okay.
Sir, how long will you take class?
After that, this whole thing is done, right? Graph part is done. And basically the graph part is done. Now natural part is just a definition only. And then a composite function won't take more than half hour. It's easy thing. Okay, basically I will close up by 11. Okay. as you have told me, like, sir, please go through the scratch thing, like from the basic thing. That is why I'm going in a slow pace and I'm explaining each and everything. What are the things are there for exponential function? Okay.
Yes, sir. So it is very
I
helpful,
think
sir.
that would be helpful for you, no? That's the
Yes,
thing.
sir.
Otherwise, I can just write the definition and then move
No, no, sir.
forward.
So this
No
is
issue.
very good, sir. Thank you, sir.
Okay.
So can we take 5 minutes break?
Yeah, okay, you can take 5 minutes break. Okay. What's the time now? It's 10:14. We will meet by 10:20. 10:20.
Thank
If you need break, please ask like that, okay? Because in that break you can ask any general doubt if you are not going anywhere. You can ask any doubt, any general doubt, general thing. Okay.
So I have a question.
Is,
Like,
is
Yes.
anybody,
in poly.
do we discuss the
Hello.
question paper of the quiz one?
Most probably TSSN will be there for.
Oh, okay.
So something of a polynomial x power n, where n is a odd degree, then it's a 1 1 function, right? So
No.
like x power 1, x power 3, x power 5. No, sir, not a whole polynomial I'm asking. I'm just saying x power 3 only, like f of x, x power x of n power.
This kind of thing.
Only n, sir, not 2n plus 1, only n, where n is equal to odd degree, like 1, 3, 5.
And
Yeah.
or n is odd means that only. N is odd means n is
Yeah, okay.
of the form this.
Yeah,
Okay,
okay.
this is
Yeah, okay,
even
fine, sir.
and then
Yeah, fine.
plus 1 is odd.
Yeah, fine.
Okay,
Fine,
yes,
fine.
yes, this is what. Okay.
And what about the minus x power n?
And n is odd.
Yeah.
Still n is odd.
N is
What
odd.
does it mean?
It's same.
Same.
It would
1
be
1
from
function.
other way. Yeah. Yeah, 1 1 function.
Yeah.
Yeah.
So basically, if you will see x cube graph, your x cube graph is going like this.
From positive, yeah. Okay.
Yeah. So this minus x cube graph will go like this.
Would be from other
No
side.
issue.
Okay. Okay.
Yeah, that will
Yeah.
be other side. Just mirror image of the positive.
Okay.
Okay, I'm just coming in 2 minutes. Okay, I just am taking water. Water. Just Shall we start now? Session is continue. It's just 5 minutes late, okay?
Yeah.
The state is decrease rapidly, just like exponential function. 16 is there only.
Yeah.
Okay.
Quickly decreasing.
Yes, exactly. Okay.
So,
So,
now in the quiz, I mean, this is just not the portions related to this session. It's about the quiz. One of the questions in the quiz about the multiplicity. I made a very silly mistake in that because I knew it was either. I mean, it should have been an odd function. I mean, odd multiplicity. They said -1 and 1 has the same multiplicity. That was the question. Did you have a chance to look at that particular question?
yeah, same multiplicity, like that question was
Yeah,
like
but
this.
they said
That kind of
-1
graph was there.
Yeah. So the curve was very steep, and in the other one the curve was not so steep. But I didn't really recognize that during the exam.
That kind of graph like that here, one.
Yeah. So for -1 and 1, it was cutting the x-axis.
Yes.
I made
That
a
kind
mistake.
of graph was there, I guess. Like
yes.
I don't know why it is going.
But see, visually, we couldn't really recognize that the two curves were different.
See, the thing is here, if they are saying, I don't know why it is going like that.
Yeah.
The question was like that, right? Here is -1, here is 1. So basically,
Correct.
same multiplicity is, it means there may be possibility the multiplicity is same is meant. See, multiplicity is same, right? It means that either if the multiplicity is same, means that, see, in this case, we cannot say about this multiplicity, right? We can
Correct.
only say, yeah, there will be odd multiplicity only.
Correct.
Right. But the thing is odd, but it can be equal. So there will be one term may be same. So that is correct option. May be
That's
same,
what
it means that correct option.
I see. Okay.
It's correct. Maybe same, what does it mean? It's correct.
Okay. So I said yes, they are same, but that was a wrong answer. I mean, I made a mistake there.
Okay, what mistake you made?
I think they said they're equal. So I said, I mean, I ticked that. I took that option.
I think there was option that the multiplicity of -1 and 1 may be same. Not exactly same, may be same. There was option. If you have correct that option, that is correct.
Oh no, I think I was given. I mean that answer was wrong. I think.
No, the multiplicity
if they,
at both -1 and 1 is 1. That's what I think that was the
Yeah,
question.
correct.
Yeah,
Right.
because it is cutting the graph. I also thought that, okay, since it
yeah,
cuts the
if this said yeah exactly 1, then it's incorrect.
Incorrect. Oh, but why is it?
Because it can be anything now. We can say it's odd, but we cannot say both are same or both are equal to 1. It can be 3, 4, 3,
Yes.
5, 7, anything.
That's right. Okay.
Okay, because
yeah.
Okay.
That was a very silly mistake then. Okay.
Okay, can we take a raised to, yeah, we can take any rational, even √2s you can take, a raised to power e also. Okay, anything you can take. Okay, let's move further.
So was that option incorrect? Because I also marked the same thing.
Yes, if there was like there is no may term was involved in that, then it's incorrect. Multiplicity of -1 and 1 is 1, so it's incorrect. It can be any odd number, or it can like it's not necessarily like both the multiplicity are equal to each other. Can be anything. Okay.
By looking the graph, it was looking same, so I did the same mistake.
The graph is only for checking the thing that whether that thing is crossing the axis or not. That's it. Okay. Yeah, this is the silly mistake. You have to be aware about it. Okay, let's move further. Okay, so have you is there any doubt in this exponential thing? There are some property that I am just writing here. You can see proof of these properties anywhere, like any online platform. It's not that much. So properties is that for any S and T, this is not a rocket science. That is why I'm just writing this thing. For any S and T belongs to R and A B greater than 0. The first property is that A raised to the power S, A raised to the power T. It means that if base are equal, then the power will be add. Okay. Here T can be negative. Okay. T belongs to just T can be negative, anything. Just like 2 raised to the power 2 is there, 2 raised to the power minus 3 is there, then you can write 2 minus 3, which is 2 raised to the power minus 1. Okay, just kind of. Second property is that if A raised to the power S raised to the power T is there, then the power will be multiplied. S. Means that 2 raised to the power 2 is there, or 3 is there, here is 4, then it means 3 into 4, which is 2 raised to the power 12. Third one is if A and B both are different number and here S is there, so this power will be split it out like that. This all the things you have used many times, right? Many times you have used, I guess. Right?
Yes, sir.
This all the identities you have used many times. I have written here like this one. Okay, end behavior, I have already explained you what are the end behavior of exponential function. As end behavior, it means that when x goes to infinity, where the function will go. When x goes to minus infinity, where the function will go. So basically, if you have fx is equals to a raised to the power x and a is greater than 1. In this case, if x goes to infinity, your fx will go to infinity and x goes to minus infinity. As x goes to minus infinity, your fx will goes to 0. Similarly, if your a is like this, then as x goes to infinity, in this case, fx will go to 0. I have explained this thing. Minus infinity, your fx will go to infinity. Okay, this is your end behavior of the exponential function. Okay, so why we have learned this exponential function? As you can see, this is an example of 1-1 function. Okay, and also this is an example of what? This is an example of increasing function or decreasing function as well. Okay, strictly increasing, strictly decreasing, you can say. Okay, let's move further for composition.
Okay. Okay.
Okay, so I am giving you an exercise. Make a graph of 2 raised to the power minus 1 minus x plus 1. This is your function. Just make a graph of this. This is your homework. Okay. Okay. One more thing is there, which is natural exponential function. Natural exponential function. Exponential function. So basically, if you will put a is equals to e, in this case, then this function will look like fx is equals to e raised to the power s, or in this case, this function is known as natural exponential function. So many of you are aware about this e raised to the power x term, right? So many times you have seen this kind of thing, right?
Yes.
So in this case, this is known as exponential function, natural exponential function kind of. Okay. This thing basically it is used as the interest, calculating the interest kind of thing, the compound interest kind of thing. If you have seen that formula 1 plus r by n raised to the power n r something, that kind of formula is there. Okay, so basically in this case, if n is goes to infinity, it will converge towards e raised to the power n. So that kind of formula is there. You can search it on internet as well.
What is E, sir?
E is just, it's a Euler constant. The value of E is around 2.17 something. It's an irrational number. Okay. Euler constant, known as Euler constant. There is a long story behind this Euler constant. I am not going to it. You just go and search by online. Okay, you will find it behind the item. Okay, it's very, very important. Like this Euler constant is very important. Okay, let's move to the composite function. So basically, this since 2.17 is there, so E is greater than 1. So all the graph will behave like this. A is greater than 1 thing. Okay. Okay, then composite function. Composition of a function. Have you heard about this composition of a function? Huh? Okay, one more thing that we have, we forgot to mention reversible function, right? Reversible function we forgot to mention. Okay. Okay, so what is reversible function in 1-1 function? So basically, if a function is 1-1, then we will say it's a reversible function. Why we will say it's a reversible function? We will see further. After composite function, I will explain why it will be. See, I forgot. No one is remember me that reversal function is forgot. Okay, so let's see composition of a function. Then we will discuss what is reversible function. Only 3 topics are remaining: composition of a function, inverse function, and reversible function. Basically, it's a one topic only. So, what is composition of function? So, yeah, Anand, what is composition function? Please unmute yourself and then let me know.
Sir, if a function is inside another function, it's called composition, like f of g of x.
Okay, so basically, the composition of a function f and g is denoted by FOG or GOF, whatever. Like both are different things. Let take one by one. FOG and is defined as FOG of x is equals to f of g of x. So basically, in the initial case, in the when we were talking about definition of a function. In the definition of function, what we have seen? We have seen that there was an input set. Okay, and there was an output set, and this function is taking some values from the input and giving me some outputs, right? That we have seen earlier, right? In the definition of a function. In this case, what happens is the input set is nothing but it will become a range set of some other function g. Okay, in the composition of a function, basically it's kind of relay race. Relay race, it means you have 3 sets. Have you seen that relay race? Have you seen that? Like,
Yes, sir.
suppose this is a ground. This is a ground. So what thing happens? Suppose this is a starting point. So player 1 start running from here. Like he is taking he's taking some flag in his hand, and he start, and there is some player 2. Okay, so he start running and run. Once he will reach to this point, like in the where the player 2 is standing, he will give the flag to the player 2, and then he will start running and he will go to the end point, right? Right? That you have seen many times. So basically, you have a set A, B, C, and here from here to here a function f is defined, from here to here a function g is defined. Okay, or you can see in a different thing. From here to here a function g is defined, from here to here a function f is defined. Okay, so basically what thing is happening, this g is taking some value from this set A and giving me some output from B. Also this function f is taking some value from F and giving me some output from C. In C. Okay, so when we will say this function will become a composite function denoted by f of g, then if this function will start working only when this function will complete the work. It means that this function g will take a flag from this set and he will start running and he will give a value from this set b named as gx, and then this function f will take this value and then give the value from here known as f of g of x. Got the idea? How this function is working? Basically, there is an initial function which is taking some value from my initial set A and giving me some output in set B. Okay. And what are the output is given to me? The function is taking that output and giving me the value in C. Right?
Yeah.
Yes.
Right? This is the idea. So understood what is this composition means? So basically, we are defining a function over a function. Okay, there was initial function. So if it was the function, there was some range set of that function or codomain of that function. So basically, I have defined my function f in that codomain set of a function. Okay. So basically, what are the terms are going to inside this? This is basically an element of range of G, right? Right?
Yes, sir.
Yeah.
Right. So have you got the idea what is composition of a function? Basically, it's a function of a function. Okay. There was initial function, then we have applied one more function. We can apply more function as well, like we can apply h as well. Then it will work on this function. So basically here the one more set will include. So what are the value it has given from here? The h function will take this value and give me another value. In this example, there is one more player 3, suppose. Okay, if you haven't seen this kind of relay race, have you seen that Chichore movie? In the last, like in the climax, there was some relay race kind of game, right? Where like what is his name? Derek will lead that relay race, right? Acid and Derek was there. He was injured in that point of moment. Have you seen that Chichore movie?
It's a relay race only, sir.
Yeah, relay race. Okay, so got the idea. Anant, have you seen that relay race kind of thing?
Sir, I've
could you
seen
please
relay
explain
race,
this
but
once
not
again?
Chichore movie.
Okay, just go and watch. That's my recommendation if you want to watch.
Sure, sir.
Okay, Chichore. It's a very good movie based on hostel life and based on real life kind of.
So
It's a very
once
good
again, could
movie.
you explain this?
So what I am saying basically the function, the composition of a function is nothing but it is denoted by FOG, and sometimes you will denote it by GOF. In this case, this is equals to G of f of x. Okay, so basically, basically a composition of a function will denote by FOG, and it is defined as like this. Defined as like this. So basically, what this function is doing. The input set of the function f is nothing but it's the output set of this function, right? Gx.
Yes,
Sorry. Right. So basically, it is operating on the initial function gs, right? It's operating over a function gx, right? So basically, it's a function of a function.
Yeah.
Right. There was initial function. And on that initial function, we are operating one another function. It's just like suppose you have a function fx is equals to x and gx is equals to what to say? Suppose x plus 1 or 2x plus 1, fx plus x square, suppose. Okay. So if you will operate this function, so basically what it is? g of x. So it means that what was your initial function? X square. So you are operating on gx. It means that in this. So basically this is what? 2x plus 1, right? Gx is equals to 1, right? 2x plus 1 only, since gx is equals to 1.
Yes, sir.
Right? So
Yes, sir.
Yes,
this
sir.
is that. So basically, this function is what doing? What are the inputs inside it? This function will square it. So here input is working as 2x plus 1. So what it will be? It will be 2x plus 1 whole square. So this will become your composition of a function.
So what about the same if g of f?
Sorry, if
Like
you
it
will
would
talk
be
about
like
GOF, if you will talk about GOF, it will be what? G of f of x, right? So basically what? What is your f of x? F of x is x square. So x square, it means that g of x square. What does it mean? So basically what this function is doing, what's the purpose of this function in real life? I will let you know what's the purpose of this function in real life. Okay. Okay, coding is one more thing, but another things are also there. I will explain. You will definitely enjoy. So what this function is doing basically, what this function, you have seen this relay race, right? This is also an example of composition of a function as well. So many things we are doing in our real life, they are related to the function, but we are not aware about it. That's the thing. I will let you know. Okay, there are nice example. Okay, so what this function gx is doing here? This function gx is doing, it is like it is behaving like this. Whatever the things are inside this function, like inside this function, it is just twice is and add 1 into it. So basically here x square are there. So he will twice the x square and add 1 here. Got the idea behind it? So g of will look like this.
Got it.
Sir, could you explain
Okay.
g of x square once again, please, sir?
G of x square. So basically, f of x, you have to put the f of x value. What is the value of f of x? It's x square only. So it will become g of x square. Now, what g of x is doing basically? So what is the input are there inside in g of x? So it will twice that input and add 1. Right? So here, input is x square. So it will twice that x square and add 1. Right?
Yes.
For simplicity, this x will be removed by f of x. Okay. Okay. Similarly here, this gx, this x square in x square, this x will be removed by gx. Got the idea?
Yes, sir.
Got the idea? Okay,
Yes, sir.
let's talk about its real life uses. Okay, so have you seen the calculator, everyone?
Yes, sir.
Yes, sir.
Okay, calculator is there. Now, if I will say, just calculate the value 2 plus 3 multiply 7 minus 3 plus 2 multiply 11 by 11 divided by 47. How will you multiply it? How will you calculate this all the things? Firstly, you will calculate the 3 plus 7, right? 3 multiply this, all those things, this multiplication and then division part, right? Board mass, have you heard about this
Yes,
board
sir.
mass kind of thing? So
Yes,
you
sir.
will solve this bracket. So
Yes,
what you
sir.
are doing basically, suppose this is your one function. So basically, what are firstly you will calculating this function. You are getting some 21 here and then adding this. So this is another function. Then you are subtracting 3. Okay, here also you are operating another function. So you are using different function and taking composition on it, right? Getting the points?
Yes, sir.
Yes, sir. Yes, sir.
Right? You are taking different function, though it's looking like it's not looking like a function, but it is considering as a function, right? Here 3 and 7. So I close this bracket, I firstly resolve it and then I am adding 2. So it's behaving like a function. It's not talking about this kind of the 3 and 7. If I will take any arbitrary value for this BODMAS thing, so I will get a function, right?
Yes, sir.
right? So it's a function and it's a composition of a function. This is one more example which is used in calculator. Okay. Another thing that if we will talk about real life thing. So if one is this relays thing, another one is what? Have you seen that jalebi making procedure?
Yes, sir.
Yes, sir.
What it will be? What it will be? Basically, there is a container. Firstly, they will make a paste, right? Okay,
Yes,
so
sir.
this paste is suppose a function f1. Now, after that, this paste will, with the help of some instrument, this paste will be go into the kadhai, and this will be like this. This is another function f2. Now, after properly frying this, they will dip in some like what to say,
Sugar
what
syrup.
yeah, sugar
Sugar
syrup
syrup or
and kind
sweet.
of thing, or whatever it is. Okay. So basically, this is your F3. So basically, initially there was a paste, or this paste is also made by something, right? So initially there was a paste. We took that paste on into some instrument, and then we applied that function, and then the function is this frying process. This is also in function. So he changed that my initial thing into something, and this F2 will change. After changing this, we have applied this, and then my jalebi is taiyar. My jalebi is ready, right? Right?
Yes, sir.
Understood the real life explanation, if
Yes,
I
sir.
am able to explain this thing. Okay, so basically we have so many examples surrounding us, but the thing is we are not aware about it. Okay.
Yes, sir.
Okay, wherever changes is happening, it means that composition of a function is happening. Simple. In day-to-day life.
Yes,
Okay.
sir. It's at many places.
You can see many places. Okay. Now composition of a
Sir,
function is done. So basically, yes.
sir, I have a doubt. Like, if
In
there
jalebi
is,
making process. In jalebi
sir,
making process. Sorry, I'm not. I don't have any idea about this jalebi making process.
sir,
Yes.
sir, am I audible?
Yes. Yes. You are audible.
Okay, if there is something like 2 power 3, 2 power
Yes.
2 power 3.
Two
Sir, not
power three
2
is
power
there.
3, 2 power 3.
2 power 3. Yes.
Yeah, I have come across this
Whether this is
kind of
the exponential function.
confusing. Yeah, in this case, we have to consider it like 4 power 3 or like 2 power 8. This is
If
my
bracket
question.
is not mentioned, it means that it's a 2 power 8.
Mm-hmm.
Okay. If bracket is not mentioned, if bracket is mentioned there, it means that it's a 4 power 3.
Mm-hmm.
Okay,
If
because you are
bracket is
calculating 2 raised to the power 2 and then calculating 2 raised to the power whole raised to the
Two,
power 3.
two power
If bracket
six,
is
if
right?
involved,
bracket
so
is not mentioned,
yeah, it
How it
is
is
2
two?
power 6 also. Both are same. Bracket is not mentioned, it means that firstly you will do 2 raised to the power 3 and then then it will become 2 raised to the power 8. Firstly calculate the above one and then calculate the further two.
okay, that means if bracket is
Okay.
not there, then we have to calculate everything except the base, and then we have
Yes. Yeah,
to.
now there is a possibility that it can be like that 2 raised to the power 2 raised to the power 2 raised to the power 4 like this. Now here
Yeah,
also
like
bracket
if
is not mentioned. So firstly calculate this, then calculate
okay,
whatever thing is, yeah, 2 raised to the power 16. So calculate this, then calculate this,
2
then
power 4,
calculate this,
16,
then calculate
16, 2,
this.
2 power 16.
Sir,
Okay.
how it is 2 to the power 8, sir?
2 cube is 8.
Here 2 raised to the power 2 raised to the power 3. There is no such bracket involved here. So it will be, this is basically 2 raised to the power 3. Okay, not 2 raised to the power 6. It's not like that. This is not equal to 2 raised to the power whole raised to the power 3. Okay, because this 3 power is only for exponent of this 2 in this 2, this base. Okay, not the whole term. So this is why firstly we have to solve this 2 raised to power 3, which is 8. Then we have to apply this 8 here in place of 2 raised to power 2 raised to power 3. Firstly, we have to calculate this thing. We have to solve this thing, and then we have to apply it.
Okay, sir.
Okay,
these are
brackets are normal, sir. Yes. Let's move further.
Yes, sir.
So basically, what we have seen here, what we have seen in the definition of this composition function, we have seen that for g of x, what we have seen, this is, suppose this is there. Okay, so if we will talk about the domain of this FOG, okay, see, range we are not talking, we will not talk about the range because it depends on the function, but yeah, we can talk about the domain. So if we will talk about the domain of this function FOG, so firstly, since in x, you can see firstly g is operating, right? So if g is operating, it means that this x has to be there in g, right?
Yes,
Right?
sir.
So basically what? X has to be their domain of G. Right?
Yes, sir.
Right. Now, if once X goes to inside domain of G, and suppose your function is defining like this. This is your one function, A, B, C set. A, B, C. Function is defined like this. Now, here G is applying. You are getting Gx. Now, there is a possibility that this Gx is not inside this F, right?
Yes, sir.
Right? The domain of F, there is a possibility because here I can say, yeah, there is a B prime which is contain this B. Okay, or we can say there is a small set in this B, B prime, from where to where function is defined F. Okay, so there is a possibility that this Gx is not inside this F, domain of F. Then this function will not work, will not work on Gx. For example, if I will take fx is equals to 1 by x and gx is equals to x square. So for x is equals to 0, if we will talk about this f of g of x, so for x is equals to 0, this 0, your gx will be 0, right? For x is equals to 0, your gx will be 0, which is not inside domain of f. Right?
Right, sir.
Right? So there is a possibility that the gx will not belongs to this. So in this case, x cannot be inside f of g, right?
Yes, sir.
Because this f will work on the gx, Now gx you are getting 0. So for x, for those value of x for which gx is getting 0, we will not use in this example. We will not take those value of x for which gx is getting 0, right? Because 0 is not inside the domain of f. So in this case, x belongs to f, and simultaneously corresponding to this x, gx has to be inside domain of f.
Means we have to remove all those values which are not in domain of g of x.
Yes. So basically, if some value x is inside this domain of f of g, what does it mean? It means that this x is inside domain of g, as well as for corresponding this x, your gx is inside domain of f. Right?
Yes, sir.
So we will include all those points of x which are inside domain of g, and for which f of g of x is inside domain of f. Okay?
Yes, sir.
Well, for example, let's take an example. Fx is equals to 2 by x minus 1 and gx is equals to 3 by x. Okay. Can we tell what will be your FOG in this case? What it will be? What is your f? This is right. Your x will be replaced by gx. So it will be 2 by gx minus 1. right?
Yes, sir.
What it will be? 2 by 3 by x minus 1, which is
2x
equals to
by 3
2x
minus x.
upon 3 minus x.
Okay. What will be the domain of FOG? Just tell me about domain of FOG.
Real number except 3.
X should
From
not
here
be
you can
equal
see
to
real
3.
number except 3. But whether does it is true? You are saying x can be coming from this. Does this thing is correct?
No, x cannot be 0 because it is 3 by x.
Exactly. So
Yes, sir.
firstly, you have to check the domain of C. Here, I have told you before, no? X should have to be inside. Firstly, X should have to be inside domain of G. So basically, what is your GX? GX is there. So firstly, X should has to be there inside a domain of G. But domain of G is what? It's R minus 0. Okay. So we are not considering 0 also. Also. Okay.
Means all real
So
number
basically,
except 3
what are the
both.
value we will exclude? So we will not take x does not belongs to domain of FOG. For that, firstly, if fx is not inside domain of G, okay, firstly, we will exclude all those points for which x does not belongs to domain of G, or if x belongs to domain of G, then G of x does not belongs to domain of F. Okay. We will exclude all those points in the domain of FOG for which if x is f is not belongs to domain of G, it means what? Either x does not belongs to domain of G, or if x belongs to domain of G, then Gx does not belongs to domain of F. Got the idea?
Sir, can you give one more example, please?
In this example as well. Okay, let's take one more example. Suppose fx is equals to root x. And gx is equals to what? X square plus 1. Now, what will be your FOG? FOG is what? Root over x square
Root
plus
x
1.
square minus plus 1.
Right?
Yes, sir.
For this case, you will say, sir, any value you can take from R. In this case, you can say like that. Okay. But,
Yes, sir.
But if I will say, what about G of F? Okay, in this case, you can take any value. But what about G of F? It will be G of F of x, right? Right?
Yes, sir.
Which means only positive numbers can be taken.
Okay. G of F of x is what? Root x whole square plus 1, which is equal to x
plus 1.
plus 1. You can say like that. So here from someone will say directly see this and he will say, sir, R will become your domain. But it's not right. Because firstly you have to check the domain of F. Firstly, x has to be inside domain of F. And if it is inside, then your f of x has to be inside domain of G. In this case, G of case. G O F of this case. In this case, this kind of thing will happen. Right?
Yes, sir. Understood, sir.
Understood the idea? So,
yes, sir.
If you will see the domain of F, you have to exclude the like negative part, right? This part you have to exclude.
Yes, sir.
So, what will be your domain of F?
We will exclude all the
0 to infinity.
Okay, 0 to infinity is the domain. So
yes,
basically you got the idea how we will calculate the domain for the composition case. Right?
Yes, sir.
Okay. Let's move further. This is the last topic, the reversible function or inverse function. Okay, I will what was it? Inverse function. let us say inverse function. So basically reverse function is nothing but if a function is 1, 1, then we will say it's a reversible function. That's the definition. Why we will say reversible function, I will let you know. Okay. So basically if a function is 1, 1, reversible function. So a 1, 1 function, 1 to 1 function is known as reversal function. Okay. Why it will be, I will let you know after this inverse function. Okay. So this is the definition of reversible function. If a function is 1, 1, then it's known as reversible function. Okay. It will the class will be like 15 minutes, more than 15 minutes it will not go. Okay. Just wait for 15 minutes. All the things will be repeated. Okay. So basically what is inverse function? Inversible function or inverse function, whatever it is, or inverse of a function. So suppose f is your function, f is another function, and g is your another function. If your f of g of x, which is also known as f of g of x, is equals to x only. So what basically you have done? This is your set, this is your set, and this is your set. A, B, C. F, I'm sorry. G, and this is F. What you have seen here, you took an x naught from the initial set and you applied this gx naught here. Applied g on this x naught. You got the some value in this b, right? Suppose this is your gx naught known as y naught. Suppose this is your y naught value, right? Now
Yes,
you are applying the f value in this gx naught. You are applying this f on this gx naught, which is also f of y naught, you can say. But the thing is, you got your initial value. Okay, you are starting from this x naught, you apply g and you got a gx naught. Now again you applied this f and you got this x naught. It means that your initial value you got, right? So this thing can happen only when this c will become your a only, right? Right? Because this
yes,
x naught is a part for this a. So if this is happening for all x belongs to a, then this g or this f is said to be inverse of f. Similarly, if this for g also, and again, if you will
Is said to be
see the
inverse of
another
f.
way around.
Sir, I didn't follow that. F is said to be inverse of f.
G.
Okay.
Okay. Inverse of g. And similarly, if you will see the thing that, yeah, if you are applying this kind of thing and you are getting this x also, so here you will say this g is a inverse of f. Okay, so the thing is, for every function this g cannot happen, right? In general, right? For every function this will not happen, may not happen.
Yes, sir.
Right?
Yes, sir.
So for those function for which this g and f exist, that those function is known as invertible function. Invertible function. Okay, got the idea?
yes, sir.
F is said to be invertible function if there exists a g such that f of g is equals to x and g of f is equals to x. Okay. Okay.
Yes,
Got
sir.
the
Okay,
idea?
so we have to check for both f of g and g of f.
Exactly. But you don't need to check both. If you will check the one also, then it will be fine. No issue. But yeah, sometimes you have to check both. Like there is an example, like if the cardinality of the sets are different, then you cannot say like that.
So, sir, if you
Okay,
scroll
sir.
up a little, Here. So we are taking the range of g of x and getting back the domain of g of x. That is what
Exactly.
it essentially means, right?
But the thing is, what are the value you are taking as input? Okay. See, getting range and domain, it's a different thing. There is a possibility that you will get x plus 1. Still, for that also, you will get that domain thing. Okay. There is a possibility that you can get like that. But the thing is, basically, the point is getting the exactly same value what you have started initially.
Okay, got it.
Okay. If you started with x, you are getting that x only. You are not getting any value of y kind of thing from this set.
Right.
Similarly, if you are starting from here, you got like after applying GS, you got here, and then after applying GS, you have to return back. It's a return back policy, you can say. If I want to go Delhi, I will sit on a train from Chennai to Delhi. I will reach out to the Delhi, and then I will for returning case, I will sit on the another train which is coming from Delhi to Chennai. I will sit on that. I will return to the Chennai and at the same point. Okay, that's the thing that we are saying. Like that returning process I am doing. Okay.
Right. Got it.
So if see this thing cannot it will not exist for every function, right? This f1g kind of thing will not have exist for every function. So for those functions this thing has exist, then we will say this function is inverse invertible function. Okay, got the idea?
Yes, sir.
Got the definition? Okay, now here is a theorem. Theorem is known as if a function is 1 and onto both then if a function f is 1 and onto both, then f is invertible. And also this is also known as bijective function. Okay, this is also known as bijective function. What the idea? Okay, this is an theorem. If a function is 1 and onto, this function is known as invertible function. Okay. Also, if this g is exists for f, then this g is denoted by f inverse. Okay. Okay.
Yes, sir.
This g
Pardon,
is
sir.
denoted by
Pardon, sir.
f inverse. Sorry.
Could you please repeat it?
Okay. So what I am saying, if function f is invertible, then there exists an g such that g of f of x is equals to x and f of g of y is equals to y, right? This thing is happen, right? For invertible case, this both thing will happen. Like from which point you are starting, you are getting that point only. Now, in this case, this g is known as inverse of f, and this f is known as inverse of g. Okay, vice versa. And vice versa. But the thing is, this g is denoted by this f inverse. Here, caution. The caution is that this f inverse is not equal to 1 by f. Both are different. This f inverse is just a notation of this g. Okay, suppose for example you have fx is equals to x plus 1. Then what will be the inverse of this x? Gx is equals to x minus 1 will be the inverse of this x, right? Why? Because take this GOF value. What you will get? You will get x minus 1 plus 1, right? Sorry. X plus 1 minus 1. That you will get, right? So basically what it will be? X plus 1 minus 1, it is x only. right? You got the x, you started from x, you got the x. Similarly, other way around, you can check. So basically, this is but this is not equal to this 1 by x plus 1. So this is not. Got the idea? Basically, what things are there? Okay.
Yeah.
Okay. So my question is, sir, what is the difference between this reversible function and invertible function? So basically, the reversible function, basically, if a function can made can be made as invertible function. What does it mean? It is meant, see here what I have said, if a function is 1 to 1, then it is known as reversible function. Why does it means? Means that suppose this is your function, okay? This f is your defined 1, 2, 3, 4, 5, 4, and this is defined like this 1 to 1 kind of thing is there, or 1 to 1 corresponding are there, and one more points are there. One more point is there. Suppose this is 1, 2, 3, 4, 5 are there. So this is 1 to 1 corresponding. So this is an 1, 1 function, right? Each value is getting one value. So I can make a g, right? G from here to here. How it will be? It will be like that. If I will exclude this point 5 here, this point 5 here, I can get my g, right? From initial case, I was getting f of 1 is equals to 1. F of 2 is equals to 2. Okay, let's take a different example. Here you will confuse. Suppose this is 1, 2, 3 here. Here x0, x1, x2, x3 is here. And f of 1, you are getting x0. F of 2, you are getting x1. For f of 3, you are getting x2. So what is happening here? This is an 1 to 1 function, right? Here 1 to 1 correspondings are there, right? Now, if I will include one g here, which is operating like this, then I am done, right? Right? I got my g as invertible function, right?
Yes,
Yes, sir.
Right? So this x0 is what? F of 1 only. So I got my g. So basically, how we can get this g? If I am not excluding this x3 from this set, I cannot get this g, right? Because after that image of x3, I don't have anything for image of this, right?
Yes, sir.
Right? So for getting the value of getting this function g, I need to remove this x3 from this output set, right? Or you can say I need to work on the range set only. We have to exclude all those points which are not the part of a range set, right?
Yes, sir.
So it means that after removing some points from the output set or from the codomain set, the function can be invertible, right? The function can be made as invertible function, can be behave like an invertible function, right?
Yes, sir.
Yes, sir, it can.
Right? So this thing is happening. Why? Because the onto-ness property, sorry, one-ness property, right? So basically, this kind of function is known as reversible function. If a function can be made a invertible function by changing something in domain, is known as reversible function. Okay.
Yes, sir.
Okay. Simple.
Yep.
Okay. So this Ram Katha is end. So this is all the things. Okay. So basically, if you have session tomorrow, please tell them they please solve some question from week 5. Okay, because all things are covered basically. So just go and watch what are the lectures are there. What's the time now? Okay, 11:14. Okay, so
So
just go
please,
and watch the lectures. What are the things are there? And if you still have some doubt, you can ask in the tomorrow's session. Most
so
probably
please
tomorrow
share
I
the
will not take the
PDF.
system. Sorry.
So please share the PDF.
Yes, I will say. Thank
Yes, sir. I
you.
need.
Thank you for reminding me. Okay. What's the date today? 28.
28.
28.
Okay, if you want to contact me, you can contact via mail that I have given to you. But make sure that you will don't
Yes, sir.
mail
Yes, sir.
me. Please contact me via chat box
Sir,
because
sir,
I
you
will
can
not
share
going to.
from right side of the corner. The share
Sorry,
mention here
just a minute.
via link.
So that pink option.
You have slashes in the name, sir. That's why.
Yes, sir.
Just a minute, just a minute. Let me save that. Bye. You will get soon. Okay, what you are saying?
Nothing, sir. Nothing.
Where is the link? I am not getting. Like someone is saying you will get that link. I don't know why the PDF is not going. Where is the link?
So earlier there was an option of share in that
Share option.
PPT.
Pink one.
Okay, basically what
In
I have done, I have
Sir,
downloaded
right
this
side.
link.
Yes, sir. Here. Right top of.
Where? This one,
sir,
copy a link to
No,
the.
sir.
No,
Above
no,
the
sir.
right corner. Top.
On the
Here,
main screen, yeah.
this one.
Sir, link.
Yes, sir.
Share the entire notebook.
Sir, copy link address and then you can.
Copy link to notebook. So OneDrive only it will be copy. I cannot share this kind of thing. By it is my personal mail.
Okay, sir.
Okay, let me test it as well. This is failed.
So I guess you can share in chat box too. You can add file there.
I am adding in chat box also. I am sharing via chat box only, but I'm not able to. Someone please give your email ID. I will mail you and then you just paste it here. I don't know why it's not going via
This is
chat
a
box.
recorded session, right, sir?
This is a recorded session. Yes.
So everything is online already. Thanks.
Anyone please give your email ID. I will take that email ID. I will just email you for now. You just paste it here. I don't know why from my side it's not going. We export once again. Okay. Let's see.
So it's my student mail ID.
Okay, just it's Suraj, right?
Yes, sir.
Yeah, I'm saying good. Okay.
Hello, sir.
Yes.
So, if I'm doing my qualifier again,
Just a minute. Okay, just a minute. I'm sending a mail. Yes, yes. What you are saying?
yes, sir. If I'm doing my qualifier again,
Okay, you are doing a qualifier again.
yeah. So, am I supposed to continue with the week 5 course or
Your voice is lacking. Your voice is lacking actually.
am I audible right now, sir?
No,
Hello.
your voice is. Oh, just a minute, just a minute. Actually, my Wi-Fi session was on. Okay, okay. Okay, now I think it will be good. By Yeah,
Yes,
fine.
am I audible?
My Wi-Fi session was full.
Okay, okay.
Okay, I think sent it. You just check.
Yes, sir. So I just wanted to know if
Yes.
I'm supposed to continue with my week 5 coursework as well when I'm appearing for the reattempt.
Sorry,
So if I'm appearing for my reattempt,
your voice is too low. You are not audible properly.
one second. Hello, sir. Am I audible now?
Your voice, I am getting that much low voice, or you guys are also getting that much low?
Yes, sir, I can't hear
Same
you.
thing, yeah.
Hello, hello, hello.
You can write on chat box. You are not audible properly. Others, if you can leave the session. Okay. Thank you.
Thank you, sir.
Okay, just download it and then let me know. I will close the session after taking that out of that question. If I am appearing for my reattempt exam, am I supposed to continue with my week 5? Yes, you have to. You can like it will help you for that now. When is your reattempt exam? When is your reattempt? 24th March. Okay, nearly week to content, right? Yeah. Okay, so I will ask to them, like, if you will continue with this,
Sir,
like,
he's
it will be helpful.
sir, he won't be
For
allowed to
you.
continue in the same term. He would be asked to continue in the next term because he was
Oh.
reattempting, right? Yeah, he won't be
Okay,
allowed
so
to
you
have the
have to.
registration this time.
Okay. So you have to prepare for week 1 to 4. Like you can read, you can see. It's only up to you now. If you want to study, you can study. See, but it's not like that you can give the quiz to exam. You cannot give, but for knowledge purpose, you can take.
Excuse me, sir. Sir, I'm not able to access that you have shared that file.
It's
Okay, so for
it
that
will open
you
in
have to
OneNote,
download that
Microsoft OneNote.
OneNote thing. Only then you can access that.
Sir, PDF is working.
Sorry, Microsoft OneNote.
Yes.
OneNote. You have to download it in
Okay.
your laptop and whatever.
Sir, PDF is working.
It's not PDF. It's a OneNote form. It's not
Yes, sir.
X1. If
OneNote.
someone
Sorry, sir.
has
OneNote.
not laptop, I think. If you
Yes, sir.
guys don't
OneNote.
have laptop, I think there is a OneNote thing on the Play Store also, or iOS. I don't know. This is accessible on mobile also, right?
Yes, sir.
Oh,
Microsoft 365. Yes. On.
Can you please share the link for the phone?
So we can
Okay.
convert that file to PDF too via online. Just
No.
copy and paste
That thing
file.
I have checked. That thing I have checked. Okay. So basically the text, whatever I have wrote on that PDF, they will be overlap if I will convert this PDF. I think that you don't want, right? That will be overlap, or
Sir, can I
some
share
text
the
will be
link?
disappear. Yeah, you just save the link on the chat box.
Okay.
That's why I have to. Two first, guys. Okay. Have you guys had your lunch? Oh, sorry, dinner?
Not yet, sir. Have to.
Okay.
Yes.
Someone. Okay, just go and it's already 11:30. Please share the link here. Someone is sharing, right?
Yes, sir, I'm trying.
Excuse me, sir.
Yes. Yes. Yes.
Sir, can I ask a doubt, sir?
Yes. Yes. You can ask.
Sir, that you have questioned that you have discussed about that quiz one. I joined half of the conversation, so I was not able to uh, like hear it properly. Like what if it was why it was not correct, sir? Like it can be any other odd function. That was the reason.
Which
Sir, you're
function
not
you are talking?
audible.
I am audible now.
Yes, sir. Yes, sir.
Okay, what you are talking about, the initial thing.
Sir,
Yeah, in this case,
no, not this, sir.
which
So
one?
that
This is the
question,
only function for which one we have discussed, right?
no, that one graph one, sir.
Okay,
The
that
break
graph,
time
this
when
one.
someone was
This one?
asking. Yes, sir.
This one? Yes,
Yes.
what's the one?
So, what it's actually the answer for that, sir?
I don't have question now. That's the thing. If you have question, then please send the time into the answer.
Okay, sir.
I
So
don't
can I
have
ask in the
question.
next?
I was just expecting that this will be your question.
Okay, sir. I will ask in the next session. Okay, sir.
Yeah, if you have a question, then please ask.
Okay, thank you, sir.
You can ask me in this session also, but if you don't have the question, how will I? Okay, others you can drop off the session. Okay, you need to stay.
Okay, sir. Thank you. Thank you, sir.
Yes, someone was sharing that link, right? Please share so that they can access on mobile as well. Or you just take a screenshot of Play Store so that they will be see the what is the app and they will be download that app. If you are not able to share the link, just send the screenshot of that. Who is sharing basically?
I'm sharing, sir. Just a second.
Safe, right?
Done, sir.
Okay. So do not get any link here.
I shared PDF, sir.
It's a PDF form. There is no
Yes, sir.
overlapping thing, right?
Yes, sir. There is no overlapping.
But can you please share the link for that app also?
Yes, if you have that app, please share that.
I'm not having. I'll try. Wait.
Okay, it's showing there is an error in this document. I am not able to open this.
Sir, I shared the OneNote link. Microsoft OneNote.
Yeah, that will be fine. For phone, right?
Yes, sir. She
This
can
is not
access.
for laptop, right?
Yes.
Yes, that is fine. Okay, Bhumika, you can download it for me.
Wait, sir. Wait, sir. Wait.
I'm waiting.
So I shared another PDF. Just check if you can open it now because it's not allowing me to just create a link for it, so I can't.
No, that PDF is working. Thank
I
you.
think I've sent. I've
Okay,
sent.
okay. Oh, I think there is a problem. I,
Is it? I've sent it in the chat. Can you see that?
that question, yeah, I have.
Yeah.
Okay, this is the question.
Sir, I marked the first one, like the A option.
Okay. So here option answers you have already given, right?
Yes, sir.
Okay, so basically, are you able to see the question?
Yes, sir. Yes, sir.
Consider the following function. This okay. Yeah, multiplicity of -1 and 1 must be same. It's incorrect. Why it's incorrect? Because here, from here we can see, yeah, the graph is crossing the axis only, right? Here we can see the graph is crossing the axis. And in for that case, we can only say the multiplicity is odd, right? And the multiplicity of 1 and -1 can be same, but it's not necessarily same. It will be odd, that we can say. The multiplicity of 1 and -1 will be odd, that we can say. But whether it will be same or not, that we cannot say by just looking by the graph, right?
Sir, but it should make S shape, na, if it is for the other odd degrees.
But here, see, here just it's crossing the graph now,
Yes,
as you
sir.
can see.
So, sir, I just marked this because I thought it will be the degree of 1, because for the other odd degrees, it should make a small S shape as written in the
Okay,
like.
let's see. Let's see in the GeoGebra. Okay, so that it will be clear. Okay, will it be fine for everyone? Let's see now. If we have doubts, we can directly see the graph in GeoGebra. Where is it?
And
Okay,
sir,
I am making
also,
the graph.
why the last option is also incorrect? The number of turning points is 5. It is 5.
We will say. The turning point is
There are
what?
6. There are 6.
Oh yeah, sorry. Yeah.
Okay, last one is incorrect, right?
Yes, sir, got it.
It's the problem. Just a minute, okay. Thanks. Yeah, I think there is something issue in my laptop. It's not working properly. Let me resolve it, okay? Bhumika, are you still there?
Yes, sir. Or you can take in another section if it is possible.
Yeah, I will take this out in the Friday's class, okay? Basically, what I think is this question is correct, right? Because here SF is we can say like if directly cross, if you will see this thing, okay, here we can see it's directly crossing the graph, but S shape may or may not happen. It depends on the equation, whatever it will be, right? It depends on the equation also.
Okay, sir.
It depends on the equation. How will I say like? Okay, I will take this on the district section.
Now, if you look at the graph very keenly, I think there's a difference in the what do you call the slant of that curve itself.
This
So
one.
that particular graph, when we look at it very keenly, -1 and 1, the slant of the curve is different. Appears to
Yeah,
be different.
exactly.
One is more steep.
It's slightly greater than this
Yeah,
one, right?
one is more steeper than the other. So
Yeah,
obviously one
exactly.
might be one, the other might be three. It could be something like that. But like you
Yeah,
rightly said, we cannot determine it is must. If it had been
yeah.
may, then we might have scored it.
Yeah, basically the thing is if the if the equation is like x raised to the power n something, then there is a possibility that you will get some s shape, okay? But
Yeah.
if you will include some more term into it, so basically if you will include some more term, it will scratch your it will push your graph towards this, and your s shape will be distorted after that. Okay.
Okay.
Because
Yeah.
of the extra term, whatever you have in the polynomial things. Okay.
We feel only bad because that was a very silly mistake. I mean, we didn't think about that. That's the thing. Yeah, we make mistakes.
Yeah, exactly. Yeah. So
Thank you.
basically, that's the thing. Because of this, because of this term, whatever you have except leading term, because of this term, your this S shape may be distorted.
Correct.
That's the thing.
Yeah.
So it not happens in any odd case. If you have x raised to the power n kind of thing, so after n is greater than 1, like for odd number, n is greater than 1, you will get that essay for each odd number. But for because of that extra term, whatever you have after that, that's for that your polynomial, like the graph of the polynomial will be stretched kind of thing. Like that kind of thing will happen.
Yeah.
Okay, Bhumika?
Okay.
Yes, sir. Thank you, sir.
Yeah.
Okay. Yeah, I will share via email. Okay, just text me. Okay, good night, guys.
Good night, sir.
Good night, sir.
Yes, yes.
Sir, is this foundation course completely focused on linear algebra?
Foundation course. There is no linear algebra, I guess, if
In
you
math,
haven't taken that math 2
in math,
course.
yeah, in math 2 course also linear algebra is a complete syllabus.
You are in
When will
there
be calculus?
math 2. You are there in math 2.
Oh, no, sir. I saw in the website.
Okay, if you are not there in math 2, you don't need to be worried about linear algebra. You have to worried about it in the second term. Okay, just
In the first term also linear algebra is only there.
like in math 1, there is no linear algebra.
Then what it is? Polynomials
Math
and
done
all.
it's yeah, that's the thing. Only basic math. Whatever you have learned in the class 12 syllabus. Okay. Okay, I'm
Then
leaving the class. Yes.
okay, so then when will be calculus and geometry?
After this week 7, most probably in week 7 also.
Week 7.
In week six and week 7.
I think
Bye bye.
they're very little.
Yeah, little things.
Okay. Okay. Good night.